Write this down. M-A-R-S. Mars, Twitchers. Red rocks. Yee. Anyway. Don't even, Creeper. Don't even. Don't. No, I don't need link spam. Like not link spam, but I get it. I don't need that. There is. Yeah, dude. There's so much stuff. I don't even. Yeah. I don't even know honestly where to start. But yeah, we'll find our way through it. Anyway, yeah, like Creeper, what I'm saying is we get the links, but don't do it all at once. We'll just work our way through. The thing is, the weekend that I took off for the wedding is the weekend that the International Astronautical Congress is going on. It's basically like E3 but for spaceflight. It's yeah. It's yeah. It's yeah. Should I just DM to you? No. You can link them in chat. Just we'll work through them, okay? There's so much stuff, man. Let's you know what? Let's put on the best of the best.
Hi,
I'm Matt Ballas. I'm an aerospace engineer with NASA. I'm not. That's just the audio.
For a good number of years. And I'm here with my colleague today, Kevin Burke, who participated in the acquisition and deployment of the 30 or so clips that you're going to see in just a few minutes. Now,
okay.
Kevin, thanks for being here today.
Glad to be here, Matt.
No.
What you're going to see is what I consider to be the best of the best state-of-the-art imagery.
I will be back
on both film and high-definition video that the Space Shuttle program is capable of producing today.
I'll be back in a little bit.
Not only does it
enjoy
serve
these
a
nice views
technical
of the
purpose,
shuttle,
and we'll get into a lot of that detail as we get into the movies here, but it also serves as an enormous inspirational and educational aspect for all of NASA's stakeholders.
You want orbital mechanics today? I mean, I could do orbital mechanics. All you got to do is ask. This has the shuttle in it too, guys, so it's okay. I'll be back in a little bit.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the Earth was flat, but around 350 BC, Aristotle proved that the Earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the Earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion, known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits
with the Sun at one focus and the other focus empty.
Applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the two foci coincide. Kepler's second law, the law of areas, states,
The line joining the planet to the Sun sweeps over equal areas in equal time intervals.
when a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the three Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a 3-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by 3 orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits, such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch, measured eastward from due north, is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees, This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes, from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the Space Shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The Space Shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 Space Shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system referred to as ohms are required to place the orbiter in its final orbit. The OMS 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The OMS 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of two burns and is used to accomplish an orbit transfer between two circular orbits in the same orbital plane. The most energy-efficient transfer between two orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, A satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes. Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the Space Shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
Did you like it? Did you love it? Did you need it? Hello. How you guys doing? Is this the end or what? End of what? End of what? What are you talking about? The party's over. Party's over. It's not even 10 o'clock, you dummy. We need content kindly, please. Oh. Oh. All right. All right. How's this for content? You don't exist. Bruh. So, that was a video that was presented over the weekend from the IAC. A lot of people are already talking about, but that's called SUSY, which is the Smart Upper Stage for Innovative Exploration. SUSY is literally just the space shuttle with no wings, but also it's a little bit more than that. This is a vertical takeoff and vertical landing upper stage. It's like I said, you got a payload bay, you got something that's going on up at the front, and then you got articulatable body flaps in 4-axis at the back, and obviously rocket engines for landing. Yeah, this is awesome. Yeah, it's like a little mini shuttle. But this is bigger than Dream Chaser, guys. From what I can tell, Dream Chaser could fit in this. It's a European DCX. Yeah. Get real DCX vibes from it. They rolled this out at the IAC this weekend. And man, 27 tons, 9 tons of down mass. That's a vertical takeoff and landing space shuttle. That's what that is. Now, I know what a lot of people are going to say. A lot of people are going to say, okay, I'll believe that when I see it. And yeah, I kind of agree with you on that one. However, the director of the European Space Agency announced that the ESA is getting a 25% increase of their funding, a 25% increase to cover stuff like that. Okay. Yeah. Careful, Kinets is getting a 25 increase. Yeah, Kinets, not the ESA. I'm sorry, you guys have too many different things over there. I can't keep track of all of it. No, so Kinets is getting a 25% increase to support stuff like this. So they're getting, the ESA is trying to get into the reusable launch vehicle business here, which is pretty damn interesting. So this right here is a biconic reentry vehicle that's basically a reusable upper stage. A couple of interesting things that I've noticed here is that the fuel tank has to be in the front. Did they say what fuel it has? No. Kuru is what it looked like, Jim. I'm going to go ahead and guess that the fuel tanks are probably up there. Yeah, for balance purposes. If I'm looking at this right, guys, it's going to have to be using some type of hypergolic system here. Now, what they noticed, what they showed this thing actually connecting to is these are ISS modules, but this is the ISS with no truss segment. So that's the Japanese experiment module. That's node 2, Destiny, node 1, PMM, node 3, Quest, Columbus, and Zarya and Zvezda are right there. There's no truss segment here, which is interesting. That's probably just a stand-in. Heck, even the Z1 truss segment is there, but it's not connected to anything, which is funny. So about the same as Dream Chaser? Dude, no. This is way bigger than Dream Chaser. We're about half the size of the space shuttle here. Yeah. We're about half the size of the shuttle. Yeah, that's big. That's about half of the shuttle's payload bay. I mean, did you see the person in it? You see the person in the payload bay? It's gigantic. Yeah, it's half. It's half the size. Interesting that they bring this onto the table, but that looks like the shuttle's payload bay. Yeah. That's very cool. And then instead of horizontal takeoff or vertical takeoff, horizontal landing like the shuttle, this thing comes back down and should go through re-entry. Body flap should keep it nice and stable. And then That's a tall order, man. I see 8 engines there. It's not the first time we saw ESA say they want independent crew access to space. Yeah, I mean, yeah, God, I understand, but also that's pretty neat. I'm not gonna sit here and say that that's not insane though. That's a lot of work. It's gonna take a lot of time to make something like that work. I would say 5 years minimum for a test flight. Operational, a lot longer than that. But yeah, that's actually pretty neat. That's really cool. Biconic vertical takeoff, vertical landing, re-entry vehicle. That reminds me of, it's basically DCX. That was the idea with DCX. Look at this thing. Or no, we gotta get the whole thing. Watch this. Ariane 6 Block 2 plans. All right, I'll check it out. Yeah, that's DCX, man. If it's supposed to do a belly flop, why is there a gap in the thermal protection system? I think it's just the render, Blue Flare. I don't think they have a thermal protection system figured out yet. Watch what DCX does, man. Watch this. So a biconic re-entry vehicle doing a VTOL landing like that is totally doable. Look at that thing.
Discovery, go at throttle up.
Yeah, Rocket Guy. That's pretty neat. You were talking about this last night on... Oh, man. You were talking about this last night on Rocket Talk, weren't you? That's when we raided. Susie is also slated to fly on Ariane 6 Block 2 with Da Vinci 2 and full carbon upper stage, P120C plus boosters, and Vulcan 2.1. I've never seen the full footage. Pretty crazy, right, RJ? Yeah. Particularly this next part. Susie, do you want TPS on the entire belly? Question. Been talking about biconic reentry vehicles for like 6 years now. That has literally been your thing this entire time. Oh. Oh, man. Dude, it's literally the same design. That's not the same exact thing, right? But it's the same basic shape. See, with the fins on the back. Yo. Oh, man, is that thing cool? Are they shutting down and reigniting specific engines? It looks like they are with air and space, but with this thing? Oh, no, high throttle ability. Differential thrust can cause thrust vectoring. And that's why it was canceled right there. Which just is really annoying. Yep. But that's basically what Susie is. Susie is DCX with a payload bay, which is... That's really, really, really freaking cool, man. Hey, Rocket Guy, you want to jump in voice and help me talk about this thing? You could tell people why biconic reentry vehicles are our savior for spaceflight, if you want to. Can I get a link to that video? Yeah, sure. DCX was insane. They were doing that in the 90s, in the early 90s, fellas. Absolutely, give me a few. All right, cool. We could talk more about biconic reentry vehicles then. So, yeah, that seems to be what Susie is. It looks very DCX-esque, which is, guys, this isn't as far-fetched of an idea as you might think. Is it rated for launch? Is it human rated for launch? Yeah. Was DCX a smaller mock-up like the X-33? Yeah, it was a demonstrator, RJ. Yep. Please. Please do that, Pythos. That would be amazing. Unfortunately, Susie technical feasibility will be decided by the economy of the ESA member states. France is putting the money where its mouth is now for the others. Yeah. It's a pretty awesome concept. Now, fellas, I'm not going to sit here and say that making something like this and putting it on the top of MLV and Kerbal is a bad idea. You know what I'm saying? You know what I'm saying?
Discovery, go at throttle up.
You speak of the 90s as it was so long ago. It was only 10 years ago. Yeah, of course. 1993 was 10 years ago, Capybara. What do you think I'm talking about? I mean, I could make this. Sure. How much weight can it take up into low Earth orbit? 27 tons, supposedly. I think I always... Now, fellas... I always made it so the MLV could have a reusable upper stage. I designed that into its capability. Being able to reuse the upper stage. Where you been the last few days? My sister's wedding, Dune. Press slide for the... Did I say 27? Yeah, no. 7 up, 7 down. Yeah, that it's not... Yeah, it can't pull what a space shuttle it could, but... Yeah, Alex, I was basing it off what you said, actually, believe it or not. So it's got to be 7 tons payload up, 7 tons down, 27 tons on the whole vehicle. Yep. So... Man, that thing is cool. Yeah, that's what they're rolling out. That's one of the things that they rolled out from the IAC. Yeah, 7 tons back turret. There you go. How was the wedding? It was great. How would they abort during powered descent? Abort? Another big line during the talk was that Susie will have a full envelope abort system, including during powered down descent. Oh. Uh. All right. Okay. If that's what you want. Sure. But anyway, yeah, that's one of a couple of things coming out of the IAC. Once again, the International Astronautical Congress was this weekend, and it's kind of ongoing right now. Here, let's check it out. They said it was going to launch on an Ariane 6 Block 2, so let's take a look here. Do you think this is any way this is worth the money? Depends. Depends on how much money you want to throw at the development, Lazarus. If you're still up for it, you're on. Okay? You guys have a lot of questions. So guess what we're doing? We're going to get I2 Ocket Guy here to help us out.
Hello?
Hey, what's going on, man?
All good here. What's going on with y'all? What's going on with you?
Everything is good. I think I got to turn you up a little bit. You're a little low. I'll take care of that now. Can you talk for me, please?
Hello? Testing? Is that better? I recently had to redo all my audio stuff, so it could be quiet. I'm not sure if it's on my end or not.
Yeah, it's a little bit, a little quiet there. Let's see if I can boost it a little bit more. Can you throw your mic up a little bit?
Certainly.
Why certainly. All right.
All right, how about there?
Oh, that's perfect. Excellent.
Cool.
All right, so Biconic reentry vehicles. You gonna give us a little spiel-orama on this one?
God, where do I even start?
So let's start with, I guess, describing what Susie is. Susie is a Biconic reentry vehicle. What does that mean?
Yeah, so Susie, a Biconic reentry vehicle is quite literally what it sounds like. It is a vehicle made out of 2 conic sections. So within that picture, you can see that nose, that first maybe third of the vehicle would be 1 conic section. And then basically from where those windows are near the payload bay all the way back would be your secondary conic section. Now, what's really interesting with BRVs, Biconic Reentry Vehicles, is that they give you a lot of design freedom. A lot of the old concepts, like if you just Google Biconic Reentry Vehicle, you'll see concepts dating back to like the 70s, the 80s, the 90s. Blue Origin had one back in 2010. ESA has been developing these since the 90s. They go back a long way. And what's really great about them is that you get all of the quote unquote benefits, if you will, of a blunt body, right? A capsule, great for drag, great for stability. But then you also get some of the benefits that a lifting body gives you, something like the space shuttle. Because what you can do, instead of making a perfectly symmetrical vehicle, like a perfect cone, you can change the overall design of the vehicle to be maybe flatter on one side. If you look up the IXV from ESA, that does it very well. But you can also see it here with Susie. The bottom is flattened. And so that gives you a larger surface area to generate actual lift. So it becomes a lifting body. And what's great about that is the space shuttle, I can't remember which concept it was, but there was a biconic reentry vehicle concept. Maybe it's the IXV. I was reading a paper where I think it is the IXV. Its lift to drag ratio is equal to the space shuttle. And that doesn't have wings, but the space shuttle did have wings. So the lift to drag ratio is the ratio between the amount of lift that it generates versus the amount of drag that it generates. And the more lift that you can create, the lower the heating on the vehicle going through hypersonic reentry. And then, of course, you can get some really, really accurate landings, like the shuttle going back to a runway. So yeah, I've been wanting to see a BRV, like a true BRV. Starship kind of does it, but not really. But something like this is in the right direction for what I want to see.
Yeah. So, okay. So what the, I mean, I heard you talk about this on Rocket Talk. And first of all, guys, if you want to know why I have a guy named Rocket Guy on the line, well, let's just say that Rocket Guy knows a little bit about, well, rockets, to say the least. So trying to think where I kind of want to go with this. So, okay, this thing is going to vertically land. What type of motor are we going to need for something like that? It's going to have to be like pressure fed or pintle or something like that. Something that you can deep throttle, right?
Definitely something to deep throttle. The other big thing, and I think we talked about this briefly in the chat last night, is what engine is this going to use?
Yeah, right.
Because something this big, they say that this thing is going to be 25 metric tons, which is really, I don't know off the top of my head what the Ariane 6 capacity is, but that's got to be kind of maxing that out, if not maxed out, and it will have to push itself into orbit as well. But that means that this being a people carrier, the engines that it uses has to be able to get away from the Ariane 6, which uses solids during max Q. So yeah, very big question as to which engine this is going to use. We were kind of theory crafting a little bit and thinking if we had to pick an engine that exists today, maybe the Avio M10, which is an upper stage engine on the Vega rocket.
Yeah.
But even that it gets you the thrust that you need, but the cross-sectional area of that engine seems a little bit too big for what because I mean, this concept, I mean, granted, this is just a concept, but they show 8 engines running on this thing. And so using 8 Avio M10s does actually work out thrust wise. Thrust comes out to be like or TWR comes out to be like 2.5 fully loaded. And so that could be enough, depending on what the aerodynamics are, to actually get you away from the Ariane 6 during an abort scenario.
Yeah.
Like I think Dragon is like around 3 or 3.5, so you don't need a lot.
Yeah,
but
okay.
It raises questions, absolutely raises questions. And maybe they'll have to do engine development, but I don't know of anyone other than CNES that really does any engine development.
Yeah. Yeah. And that's interesting that the Avios will do it. So Avios are a hypergolic engine, which means this thing is going to basically have a shuttle ohms pod like jammed into the front of it, right? Like, is that how I'm looking at this? The fuel tanks seem to be up in the front.
Another big question. I mean, yeah, so you have that payload bay. So there are obviously not anything in the payload bay. Mm-hmm. It does have that conic adapter that you can kind of see on the back, which also doesn't seem to give you much room for fuel. But even in the nose, it doesn't look like it gives much room for fuel. So definitely, I don't know how true this is to their working concept, or if this is just a complete artist render. But yeah, we were talking about that as well. Is like, what propellant would this use? And if it's going to the ISS, you're not using cryos.
Yeah, exactly. They won't allow it near it, right?
Yeah, to my knowledge, unless they want to start expanding on that capability, which I'm all for, but you got to do it safely.
Mm-hmm. Yep. Yeah. Last thing you need is depress next to the space station. That's frowned upon.
Generally speaking, yeah, that would be like the end of space flight.
Yeah. Yep. Yeah.
But yeah, going back to like the design of this, I mean, we've made them in Kerbal Space Program, and I gotta say they work out very well. But you do have to kind of cheat a little bit, as you typically do with these weirdly shaped blunt body vehicles, right? Like,
yeah.
I wish in KSP they did calculate body lift truly, because KSP doesn't. But it does come out to be the same exact problem that you have with the space shuttle, which is, how do you balance this thing? Because it's got to be able to fly stable through ascent. It's got to be able to fly stable like a space shuttle going through hypersonic reentry. And then you have to be stable in essentially a belly flop, right before you do your pitch maneuver. Which I was very excited to see that this does the 3-engine ignition Starship style of landing, and then fires the last set.
Yeah. That's crazy. And then it looks like it's got. I was gonna say it looks like it's got 4 body flaps on the back, very similar to DCX. And that's for cross range, right? Or something like it's gotta be trim it out maybe. Like I'm not sure.
Yeah, probably all of the above. If you look at the IXV had 2 body flaps that it would use for roll control and I believe for pitch as well.
Yeah.
It would probably use that for braking, trimming it out, keeping it stable using drag to make sure it does the belly flop maneuver. And then of course, it took me a little while to try and make this work in Kerbal Space Program. You will not believe the side slip that you will incur when you don't have any sort of aerodynamic surfaces in the back. So I'm sure it's similar to this. You have basically at subsonic speeds a symmetrical vehicle, which if you know anything about aircraft, the fuselage is a destabilizing part of the aircraft. Like the fuselage, if you get into a side slip, it will just get into a flat spin. So same thing with a BRV. You need to have some sort of control surface in the back to give you yaw control and that sort of thing.
So Knez put their money where their mouth is with this thing. Do you think what I mean, I know it's super freaking early and this stuff does definitely take time. You think when do you think we see this thing, if we do at all?
So yeah, the first thing I'll say with that is it's really kind of a brilliant move, and it makes sense to have this thing be dedicated to the Ariane 6. Ariane 5, right, has been crew rated for a couple decades now and has never, to my knowledge, never flown a crew rated mission, right? So like, brilliant, great, ESA, what are you doing? But now Ariane 6 is coming online, and now it actually has a potential purpose for flying a crew payload, which I really like. The second part to that is, I'm not sure if you've covered it yet, but at IAC, ESA is planning on doing a 25% increase in their space funding for the next 3 years.
Yeah, that's what I mean by putting your money where your mouth is. That's definitely enough funding to get something like that made. Like, I mean, I'd have to look at the actual numbers, but that's definitely a big increase.
It comes out to be, I think they said around 18 billion over the next 3 years. So it comes out to be like between 5 and 6 if they ramp up billion per year for the next 3 years.
That's more than enough to get that made.
Especially with Ariane 6 starting to trim out, right? Because Ariane 6 is debuting next year, beginning of next year.
Yeah.
So that means that bell curve, right? If project management and funding curves, that bell curve for ESA and Ariane Group and stuff like that should be slimming down, which makes it a great spot to now pick up a new big project to increase that funding curve.
Yeah. Huh.
So it makes sense. It's good timing.
Yeah, dude, this is crazy, man. We're gonna have a a freaking, we could potentially have a scenario where we get like Susie flying with Starship, flying with like Orion and Starliner and Dragon and Dream Chaser. Like that's. Whew. Do you think that this was built anticipating a commercial low Earth orbit economy? You think that's why they're going to try and do something like this right now?
I think this comes at a good time. I really do think this is a reactive move and not a proactive move. ESA, basically like the United States was after the shuttle was retired, doesn't have access to space except through another company. And they used to rely partially on Russia to fill up some of that cargo capacity using Soyuz. That, of course, with the uncertain times, is gone by the wayside. So they definitely seem to be looking to become more of a foothold in space for themselves. And I think the vehicle, the sizing of the vehicle and everything, 7 metric tons of payload is what they claimed. That's pretty good for a lot of expansion, especially talking about possibly using this for lunar. I mean, that's a kind of a whole nother big stepping stone, getting it rated for deep space, but it has that cargo bay which could house, deep space modules, just like Orion would have its deep space module that it would connect to before going out to Venus or wherever. That's the concept NASA has. Yep. This has an integrated payload that can already house that. So it seems to be quite adaptable. Yeah. I don't know if they've even really figured out how far this will go.
Yeah. I mean, judging by these renders, they're definitely seeing a very early concept here. But still, man, that the fact that they have this project and it's not just, oh, we're gonna plan on doing it. They've committed the cash to it, which is, I mean, that's, oh man, I can't even believe this. It literally looks like the space shuttle, only about half the size with no wings.
Yeah,
it looks about the same. It's the same exact shape because the shuttle had some biconic stuff going on, but it has wings.
Oh, absolutely.
Mm-hmm. Oh, that's so cool.
I'm excited.
Yeah,
I think this is good. I hope ESA has their ministerial budget meeting in November, and that's when we'll know if this is going to be possible.
Oh man, what a time, dude!
Truly. Absolutely, truly.
Yeah, okay, so people in chat say, I have a vague memory that the ESA kept moving the canceled spacecraft, though. Yeah, but now they have a reason to. With the full envelope abort claims, what's the chance of shielded ejection seats like I had seen for a bit? Shielded ejection seats? I don't think so. I think that the vehicle would just separate, right, Rocket?
I think it's definitely safer, and to cover more abort scenarios, I think it's safer to have your vehicle actually be the entire thing that separates. Because so I'm trying to think back to the space shuttle during the STS-1, where it had ejector seats. Like, how far into flight were those actually viable?
About 40 seconds.
Yeah, so I mean, yeah, but so yes, you could. And we do see those 4 windows there. It's kind of unclear how everything fits together, and if there is room for like that nose section to separate. But that's so complicated to issue your pressure vessel to be on solid rocket motors to separate from the craft. And then of course you have to worry about the solid rocket motors, and because the plume, you can't really fall into the plume, and that's a difficult problem.
Yeah.
I honestly think it's simpler just to have your whole vehicle separate, especially if you're using 8 engines.
Yeah, I mean, you said that the TWR, if they were using Avio M10s, would be around 2.5, which that should be good enough.
Just
it's not bad.
The only thing that's not taking into account is the drag on the vehicle at max Q, because this is a blunt body at the end of the day on the front end of Ariane 6, so maybe that's not enough. Maybe you do need something that's on the order of 3 or 4 to account for max Q, but it's an interesting concept.
Yeah. Yarg has a good question. Do you actually see this thing going outside low Earth orbit? If it uses hypergulls, I don't see it having the efficiency to ever be worth taking that far from Earth. They'd have to design refueling like Starship, and it's a ton of extra dry mass to haul, kind of like taking the shuttle to the moon. It's a good question.
Yeah, that's a good question. And do you want to answer it first, CJ? Do you want
to? Yeah, let me take a stab at it. I mean,
yeah.
Yarga, you could just put this on a bigger rocket. Can you imagine one of these like flying on the front of like SLS, for instance? That would be pretty nice. Let's yeet this on the front of a Block 1B and then give it a you put the EUS behind it and then give it hybrid. That'll work just fine. Dude, I kind of want that actually now that I'm thinking about it.
This does also have the same sort of form factor, if you will, as Orion. I mean, of course, it's longer, but it's roughly the same form factor in terms of its conic section at the very end, mating.
Yeah, can you imagine launching this thing with like a service module attached to the back of it on a Block 1B? That could work, man.
Yeah, indeed. And then the other thing, so how I would, I guess, approach that question is, okay, so SLS, that would be great. That would be great.
Yep.
The other way that I see that is, okay, let's say ESA wants to make this independent. It has a contract with NASA to go out to the moon, what have you, right? Then, assuming that Ariane 6 is still the vehicle, there could be, I mean, so a couple of things, right? One is it has 7 metric tons of payload, which who's to say that they don't make a longer duration burn variant that instead of having a payload bay has extra additional fuel, right? That's one kind of not ideal scenario. The other version is, so Orion is using hypergol, so there's no problem there for long duration missions. The other big thing that's happening in the industry, if you look at companies like Orbit Fab, there is massive growth within the commercial sector focusing on propellant depots. This is a thing that's being worked on, and they recently got several, like $100 million of investment to focus on propellant depot supplies. And there have been more academic research in the realm for where to set up these propellant depots if we want to have outposts to do something exactly like that. Let's have a non-optimized deep space vehicle be a part of a larger infrastructure to then go to and from other destinations. That's what the STS program was. Indeed. And when you do that analysis, it's really interesting because what you'll find is that once you get into low Earth orbit, it's roughly the same amount of energy to go from low Earth orbit to geostationary orbit. And then again, it's roughly the same amount of energy to go from geostationary orbit to low lunar orbit. And then once again, it's roughly the same amount of energy to go from low lunar orbit down to the surface and back. So those are really interesting destinations that make a lot of sense to have refueling depots, which makes a vehicle like this very possible to go into deep space, even though it's not currently rated for it.
And then, like, even if you don't want to go the depot route, like, and I don't mean to be stuck on it, but on like a Block 1B SLS, you could just service module this thing, like Dream Chaser Shooting Star on the back. Just put a big freaking shooting star back there, and you could carry the propellant with it. Take more prop with you. Refuel that way. Like that. Oh, man, that's got a lot of potential.
Indeed. So I think this could be used for deep space. It takes a little bit of extra work, of course, since it is more optimized for low Earth orbit.
Yep.
But with basically what that just says to me is now it's got to rely on more infrastructure, which is pretty much how expansion in every other industry ever in the world works, right? Like you look at the highway system and how that came about. We went from local roads into highway systems in between multiple cities into an entire infrastructure that spans across country, right? So that's kind of where space is going.
Yep. Oh, man.
Which again, STS proposed back in the 60s, so...
Oh, they had it right, man. It's so ridiculous. I can't believe how spot on they actually were with the shuttle program. It's just needed to fly the damn thing.
Indeed. And then, what would really be cool to see is have SLS be able to augment this system. But to do that, we have to have SLS probably approaching 4 flights a year, which Crossing my fingers.
I still say that's doable.
Yeah, indeed. And like, I know you've talked about it on stream, but and it's so true that if you can fly more, that price per launch absolutely decreases.
Yep.
And what metric I think really shines the most in terms of that, and we were talking about this last night or maybe the day before last as well, is when you look at the cost per minute to have boots on the surface of the moon, it becomes really apparent. When you do one flight a year, basically for these first Artemis missions, roughly 6.25 days on the surface of the moon, it comes out to be like close to $500,000 per minute to have a single astronaut on the surface of the moon. That's crazy. But now think about expanding that to 4. So you cut that into a quarter of the time. And then what's really interesting when we were reading an article yesterday is NASA hopes to, by 2028, I think, by like Artemis 5 or whatever, they want to expand it away from just one single gateway orbit to now expanding it to 4 gateway orbits, to where now we can stay 30 days on the surface of the moon. And when you can do that, you drop that price per minute for an astronaut on the ground to something like less than $5,000. Like 2 orders of magnitude decrease just by increasing the launch capacity and letting them stay on the ground longer. And that's the metric that speaks the most to me.
Yep. Alex says, I saw some concept images that they will use the Ariane next. It's basically a Falcon, but European. So could this reusable rocket launch Susie? It depends, dude. I actually have that video teed up here for future evolutions of Ariane 6. So I'm going to tee that up. Have you seen this, Rocket Guy?
Which one is it?
Current and future Ariane 6 launchers.
I don't know that I have.
All right, let's take a look. Let's see. I'm gonna unmute this here for a moment. Versatile and scalable by design. Okay. Gee, I wonder what that payload is. Oh my.
Well, with that increase, they now have the 25 metric ton capacity for Susie.
Yeah, but look at this next thing getting teed up here.
Oh, hello, SpaceX.
That's ambitious, don't you think? No, because this is launching out of Kourou. Whoa.
didn't notice that before with the Suzy version. Yeah, it has the 2-engine variant
Yeah.
of the core stage.
Yeah. Dude, you know what? I'm gonna go ahead. All right, I'm gonna throw this one out here. I'm, Arian 6 kind of went quiet for a little while, right? It went quiet. We didn't hear much of what was going on. Do you think they changed the stakeholder expectations to basically come up with this architecture for the foreseeable future? Or you think they had that right from the start? Like, it seems like they played adaptive here. You said this was, you said it yourself, Suzy, it's reactive, right? Like, I think a little, like maybe a couple of years ago, I mean, because this has clearly been in the works for a little while. I think a couple of years ago they said, stop. All right, we gotta change this. We gotta figure something out here.
Yeah, that's a good question, because I honestly see two different routes to it. One is, so I mean, okay, so how long has Ariane 6 been in? On average, it's roughly 4 to 5 years to develop a new launch vehicle, right?
Yep.
So I don't necessarily know if they had it at that point necessarily, but having it react to the new increase in market demand, and now that Vega, right, is doing these rideshare programs like SpaceX has started to, massive booming industry. God, it's a hard question.
Right? Yeah,
because I think it's somewhat easy for them to expand on their baseline, and it doesn't necessarily mean they change stakeholder expectations. It means that they develop their vehicle, right? 5 years of development for their Ariane 6 version 1. And then, like SpaceX, they've already started planning out a development roadmap on how they can expand using other technologies that they have probably already been developing. So I think it's a yes and no, but not necessarily going back to stakeholder changes. More like expanding on a version 2, so to speak.
Yeah.
Start with your baseline, go on from there.
Yeah, that's cool. So basically, they designed the modularity into it from the start, that's a very smart way of doing things.
Indeed, and you'll see that across the entire industry. That is very much how most rockets, I guess, since probably around the Atlas V, once you started moving away from like Titan, and even Titan had its variants, but they were more, small iterative improvements. But then once you got to Atlas V, which really truly started implementing, modular design in terms of having different side boosters that you could do, different second stage engine configurations, and then you moved into Delta, which you could do Delta medium into Delta heavy and all these sort of other things. That really seems to be the move, where now they're like, why not give us more capability, reduce costs for missions that don't need the full capacity of the large one. Yeah, you're right. It does make a lot of sense.
That's cool. Dude, that is pretty big news.
Yeah, and credit to ESA. I mean, their budget, right, is only a quarter of what NASA's is, and I'm hoping that with this quarter increase that they're trying to do, we'll really start to see ESA become a larger foothold within the industry.
Yeah. Man, that's wild. Well, dude, thanks for your 2 cents. I really appreciate it. You want to go for another one?
My pleasure. Another one? What?
Another thing. We got. I got another one here that you might be interested in. Another one.
Sure. I'm always game. I love talking space. I can do this for hours. I was actually about to ask you if you wanted me to leave, so
I'm good for the
just
duration.
kicking me out.
Chat,
just end the call when you're ready.
No. No, you can stay as long as you want. We good. Chat, you good? You good with having Rock Guy here? I'm good with having Rock Guy here. Let's bring back Max Q. Let's do this.
There we go. Done.
All right, so I'm going to read this article here. Have you lost another submarine? All right, so check this out. NASA stakeholder collaborations help inform Moon to Mars planning. So basically, they finalized Moon to Mars stakeholder expectations. I'm pretty sure you'd want to get in on this.
Most excellent. Can you link that in chat so I can bring it up as well?
Absolutely. Is a better mic than EJ? Thanks. You joke. Okay.
Be nice to EJ.
All right. So, NASA has released a revised version of its Moon to Mars objectives Tuesday, forming a blueprint for shaping exploration throughout the solar system. These guideposts in the agency's Moon to Mars exploration approach will help shape NASA investments, as well as those of the agency's industry and international partners, towards the moon and beyond. Starting with 50 draft objectives developed by agency leaders across mission directorates earlier this year, NASA invited its workforce, the public, industry, and the agency's international partners to provide feedback, and followed up with 2 workshops with industry and international partners to engage in further discussions. The resulting revised 63 final objectives, well, they added some, reflected a matured strategy for NASA and its partners to develop a blueprint for sustained human presence and exploration throughout the solar system. Oh man, okay. All right. They cover 4 broad areas: science, transportation, and habitation, lunar and Martian infrastructure, and operations. The agency also added a set of recurring tenets to address common themes across objectives. We need a roadmap. Oh, okay, that's Pam. We need a roadmap with staying power, and through a collaborative process, we've identified a core set of defined objectives to achieve our exploration goals with our partners, said Deputy Administrator Pam Melroyd, shuttle pilot. All right, anyway. These objectives are both practical and aspirational, and we were gratified by the thoughtful contributions of our workforce, industry, and international partners who will join us in shaping our future together. Oh, that's a good one, Bro Handy. We'll get to that in a second. You seem to get a bit flustered. No, just stakeholder expectations and stakeholder goals, and setting them in stone is the first step to a really healthy and robust program. Yeah, anyway.
Yeah, I'll interject there 1 second. So this is what Journey to Mars should have done in the first place, but I don't remember ever seeing any, RFIs or RFPs coming from the Journey to Mars, which was back in 2011.
Yeah, Journey to Mars was a terrible idea. Oh God, did I say that out loud? All right. All right. Let's check this out. Common themes across objectives, science objectives. I want to go to the infrastructure, transportation and habitation. This is what I wanted to see first. So, develop cislunar systems that crew can routinely operate to and from lunar orbit and the lunar surface for extended durations. Okay, I'm pretty sure we know that one. All right. Develop systems that can routinely deliver a range of elements to the lunar surface. Okay. Develop systems to allow crew to explore, operate, and live on the lunar surface and in lunar orbit with scalability to continuous presence, conducting scientific and industrial utilization as well as Mars analog activities. Oh.
NASA turned this around really fast for NASA.
Yeah.
They issued the draft in November of last year. Then they released them to the public in 2020, and then with 5,000 inputs from the industry across international partners, they then held 2 workshops, and then now we're getting them in September. Like that?
Quick.
That's pretty good for NASA.
That's really fast. Wow. Yeah, check this out. Develop transportation systems that crew can routinely operate between the Earth-Moon vicinity and Mars vicinity, including the Martian surface? Ooh, I wonder if Lockheed submitted that one.
Would like to see the Mars ascent descent vehicle. That'd be pretty cool.
Lockheed just happens to have something teed up that looks... Oh. Please make that. Wasn't I saying something about having multiple gateways and using one as a Mars transfer vehicle? Maybe. I don't know. Yeah? Look, I want that. Develop transportation systems that can deliver a range of elements to the Martian surface. Develop systems for crew to explore, operate, and live on the Martian surface to address key questions with respect to science and resources. Develop systems to monitor and maintain crew health and performance throughout all mission phases, including during communication delays to Earth and in an environment that does not allow emergency evacuation or terrestrial medical assistance. Ooh, this is nice. I like this.
That one's interesting. That one's been a small business innovative research grant opportunity for the last 3 years. SBIR, which is the government grant for NASA.
Mm-hmm.
That almost exact wording has been in there for the last 3 years.
I'm just looking around here. Lunar and Mars, incremental lunar power generation and distribution system that is evolvable to support continuous robotic human operation and is capable of scaling to global power utilization and industrial power levels. Oh. Oh my. So, all right, Rocket, just give me 1 second. What are we looking at here? Guys, these are stakeholder requirements for basically what NASA is going to do when they go back to the moon and then on to Mars. The stakeholder requirements is kind of a very, very big part of systems engineering. You know, we're going to go back to the moon. We're going to go back to the moon to stay. What does that mean? That means doing what you see on the screen. So, long story short is that what we're seeing here, especially that one that's highlighted up there, is what NASA wants to do on the moon when they get there. These are pretty lofty, to say the least, pretty lofty stakeholder expectations, but it's doable. But these are great goals for Moon to Mars objectives. These are fantastic. Develop a lunar surface orbital and moon to Earth communications architecture capable of scaling to support long-term science. Develop a lunar position, navigation, and timing architecture capable of scaling to support long-term science, so lunar GPS. Okay. Demonstrate advanced manufacturing and autonomous construction capabilities and support a continuous human lunar presence and a robust lunar economy. Jeez. Demonstrate
So everything in here is fully about basically building cities on the moon and Mars.
Can you say that one more time, please?
Every objective in here relates directly to developing a permanent presence on the moon and Mars. They're talking about identifying crops that can create a sustainable living on the Martian surface. The power grid, which we actually talked about with astrobotics. Did you see that for astrobotics? They want to build a lunar power grid. It's crazy. Robotic systems, EVA suits, transportation systems, rovers that can. Wow,
this is these are hefty goals, dude. That's what I'm looking up like that. How are you gonna do all this?
Okay, so we have the goals. Question: what's the timeline here?
Yeah, that's what I'm wondering as well. This is a lot of stuff, man. Oof. I don't know, man, but those goals, I don't think there's a timeline for it right now, but those are pretty damn fleshed out stakeholder expectations. Those are pretty good, man. And they did it fast too, which that's kind of like, huh. Okay.
They did do it fast, yeah. So
quite quick.
My take is love it, and I'm gonna be cautiously optimistic that this doesn't go Constellation, where we had all the goals and no definitive timeline or cost structure.
Don't say that.
That's it. Yeah, sorry, bringing up
don't
horrible memories.
Please. Man, those stakeholder goals were fantastic. Constellations were perfect, dude. They were freaking perfect. I get it, the launch vehicles weren't exactly the best, but also
I wouldn't say they weren't necessarily the best. They just wanted to have them developed, tested, and in operation within 15 years on a flatlined budget. Developing two very different vehicles. Can't do that. Nobody can do that.
Anyway, all right. So this has been linked like 4 or 5 times in the last 5 minutes in chat. So let's see what we have here. This is coming from Sierra Space. We are pleased to have Bridgestone join the collaboration between Teledyne Brown, Nissan, Textron, and Sierra Space to develop a crew lunar terrain vehicle for NASA to support future exploration on the moon. Huh. All right.
The timing is quite good.
Yeah. With those stakeholder expectations about building lunar vehicles, and this is what was linked. This is the reply to that. Oh, wouldn't that be something?
Yes, please.
Yes, please, Liz.
Although I have to say, those tires very impractical.
Did the Mecanum wheels on the moon? Yeah, no thanks. Way too many moving parts.
They're great for hard surfaces, but the regolith? No.
Yeah. Speaking of lunar regolith, at IAC, I'm pretty sure Bill Nelson talked about them making flat surfaces and landing pads and stuff on the moon by having some kind of spray that reacts with lunar regolith and turns it into concrete or something. I think he referred to it as a magic potion that could take moon dust and make it into a flat surface.
Please tell me they're going to name it pudding.
Oh, that would be amazing.
No, but I mean, that sounds like Maston Space Systems technology.
Yeah.
Which is, their technology was to spray aluminum powder into their engine exhaust as they're landing. It melts in the exhaust, and you basically surface the entire moon with now molten metal, which cools almost instantly. Creating your own pad.
Huh. That's a good idea. I like that.
Which is, I guess now it's Astrobotic owned, and Astrobotic is it seems very much trying to be the commercial company to commercialize the moon. They're doing everything.
Yeah. I'm just happy that, I mean, it sucks that Maston isn't independent anymore, but Astrobotic is they not only bought them, but they expanded them like crazy. They're expanding the Maston systems. Yeah, which is good. That's good. Maston basically was one of the pioneers for commercial vertical takeoff and vertical landing rockets. They had how many flights did the VTVO vehicle have? That thing had like 600 flights or something.
I was gonna say, I think it is 600. Yeah,
600 flights of a vertical takeoff and vertical landing rocket
with air restart demonstrations.
Yeah. Oh. General Mechanics Toolkit, North Las Vegas, Christian. Oh boy. Oh, don't do that to me. No more Gov Planet. Oh, I had a bad experience once.
Oh, by the way, what did that end up selling for? It's ended now, right?
The J2 or the RV?
Yeah. The J2.
It was up over 1,000 last time I checked for all the lots.
For all of them? Ew. Okay, yeah.
Yeah. And the RV
Come on, EJ, buy it.
Yeah, the RV went for 20 G's.
Nice.
The guy who bought it is going to use it to sell RV parts.
Huh.
Yep, that was my response as well.
Is he selling the whole RV?
Yeah.
Can you just buy the RV as a part?
Yeah, I'll just buy. Yeah. There you go. I'll keep those mechanics tools up. I might actually go and score that. All right. I already got that.
With your mechanical inclination, do you do you have like a welding kit, or what does your current equipment status look like
I have a welder
for your garage?
It's a crappy
Nice.
flex
Yeah.
welder, 110-volt flex welder. You basically can do body panels on it with it for a car. It doesn't it can't pen very much, and I'm not very.
What would you want?
MIG welder.
Yeah, MIG.
Yeah, a MIG would be good. A good like a 220 MIG welder would be nice. So basically, it's gonna sit in someone's yard for about 20 years. Yeah, there are pretty nice welders in that link. Why do you ask, Rocket?
No, because I know you've been trying to get your garage situated and your car streams and stuff. So I was just wondering what you had, since you were being linked welding equipment and stuff like that. So.
Oh, yeah, no, I don't have. I have a little Harbor Freight stick welder. It's not very good, but I did get. I bought a nice metalworking vise, and I have a little drill press now that came. that was. That's a story. And then I have a bench grinder for making metal parts, for like deburring metal parts. I bought a set of files. I bought a set of metal punches. Yeah, what I would like is a MIG welder, a lathe, and a CNC mill would be really nice, but I don't think we could. I don't think that's in the cards.
That's a big check.
Yeah, that would be expensive. We'll just go with the welders for now. Like, I just need a good gas welder so I can do we could do frame fabrication and stuff. Like, if I wanted to mess with suspension and stuff, we could do that.
Nice.
Yeah. And like, actually, you'd kind of think this is cool. What I was thinking, like, down the road is, I have we build like 3 or 4 of the same engine, and then you go on road trips, and then you take the engine apart and you see how it wears. So like you basically put engines through tests, right? Like you would with a rocket engine. You push it to its limit, and then you take it apart, and you see why, like what's going on inside. Like, you go look at the guts and you assess the thing and go from there. And like, I have 5.0 V8 serial number 1 and 2 and 3 and 4. Basically just run them through testing regimes like what you would with a rocket engine. I think that'd be kind of cool.
Yeah, that is actually pretty awesome. Because I love seeing the videos where they take an engine and then basically cut it in half and put plexiglass light, right? So you can see at least half of the motor running. Yeah, that would be able to do that with an actual running motor for long distance rides. That'd be pretty sweet. Yeah,
that'd be awesome. The other thing that we were thinking is take the onboard diagnostics and find a way to stream that data to the stream while we're driving, so people can monitor the status of the vehicle while I'm driving it, which would be kind of cool.
That would be insane. Okay.
Yeah. You found a lathe. Yeah. Draw past. We'd have to get an engine dynamometer, but we could get a test stand for the engines. Sure. All right, Alex. I'll see you, buddy. Bro, Andy, I haven't. What was your question? Ask me again. In the meantime, I'll just show some quick stuff here. So ULA is getting Delta 4 for the L91 mission ready to go. And yeah, it's like one of the last Delta 4s.
3 left. Last one from the West Coast.
That's a shame. Any word on what Slick 6 is going to do after this?
Asking me?
Yeah.
I have no idea. No, I have no idea what they're planning on doing. Well, you think it'll be refit for Vulcan? What are their Vulcan plans?
I think Vulcan is going to end up at Slick 3. I've heard things about Slick 6 and what they plan on doing with it, but I don't know if there's any validity to them. You know what I'm saying?
I don't know. I mean, ULA is is slightly better than Blue Origin, but it's pretty much only Tori Bruno that gives us any word of what's going on, and he's also not, exactly like Elon and SpaceX are.
Yeah, for real. Okay, so Brohandy actually has a pretty good question here. Is the second contract for NASA a way of hedging bets on Starship for HLS? So you're talking about sustainable lunar development, right? SLD? I think it's more that they want 2 landers. But yeah, apparently I know what spurred this question. They modified Appendix P for Next Step 2, okay, HLS SLD.
Mm-hmm.
And they released the new solicitations for them. Hold on, I will get them right now. I gotta find them. One moment.
Well, for one, it's definitely to appease Congress.
Yeah.
But we wouldn't even be in this situation in the first place had Congress given what NASA had asked for 3 years ago.
Bingo.
Because NASA originally asked for like 3.2 billion, I think, for HLS, and they were given 832 million. So, less than basically a quarter of what they were asking for. And then they chose SpaceX because that was the only feasible solution, and then Congress freaked out. So,
Yep.
So this is what they wanted to do the whole time, but Congress.
Yeah, I think Congress got mad at NASA that they picked the wrong landers, so to speak. But also, I very much think that was a calculated move by Jim. Exactly, Pete. Jim knew this is what would happen and why he single sourced to SpaceX. That was like 70 intergalactic chess. One of the most legendary NASA moves I think I've seen anybody ever do. I think that's what he did. I'm pretty dang sure. So let's check the BAA here. Let's see what we got. Added Appendix P draft broad agency announcement. We gotta go down. Okay. Okay. This isn't the right one. Let's go back over here. Ooh, all right. Let's take a look here.
I also think, if I recall correctly, Space News may have had an article that summarized some of the stuff.
Yeah. Let's go see what Yef is up to. Yep, there it is. Yeah, Jeff Faust released this 2 days ago. Let's see. NASA has released a request for proposals for a second human lunar lander for the Artemis program to join Starship, the Starship lander under development by SpaceX. NASA releases a call for proposals September 16, nearly 6 months after announcing plans for sustainable lunar development, and releasing a draft call for proposals for industry feedback. The agency set a deadline of November 15th for receiving proposals, with an award expected in May of 2023. The selected company would develop a lander that would support missions after Artemis 3, first crew landing of the Artemis campaign that will be done by SpaceX no earlier than 2025. Hey, Tactical. The winning company would carry out an uncrewed landing followed by a crew landing no earlier than the Artemis 5 mission in the late 2020s, then be eligible along with SpaceX to compete for lunar landing service contracts for later missions. Pete, what are you saying there? Hold on. We were at real risk of the whole dang thing being canceled or kicked down the road again. Jim made sure it didn't happen and knew that the politicians would make sure the better connected got their funding for a second lander. Yep. No, it was a great idea. Great idea. I saw it right. I'm not gonna say that I predicted it, Pete, because I did not see that one coming. When they announced Starship for HLS, I went, what? Okay. But yeah, definitely an amazing move by Jim. Really, really smart. And not to say that Bill isn't doing some really good stuff right now either. He's done okay. Okay. All right, here, let's see. The winning company for SLD will have to demonstrate that its lander can meet the requirements for a notional lunar landing mission called a polar sortie mission. That mission would carry 2 astronauts to the lunar surface for a stay for up to 6.25 days and support 4 planned and 1 contingency moonwalk. A later polar excursion mission would require the lander to transport 4 astronauts to the lunar surface and stay there for 33 days. That mission would assume there are other assets at the landing site, like a habitat where astronauts would stay during the mission, and thus require only 1 round-trip moonwalk from the lander to the habitat and back. Companies can also show how their landers could support short-stay missions to regions other than the South Pole of the moon. Companies can also show how their landers could support short-stay missions to regions other than the South Pole of the moon as well and be used to transport cargo. Excuse me, Rocket. When moonhop?
Yeah, I'm really glad to see that because that's been something NASA's been going for on the small level for a very long time, basically developing CubeSats that are designed to go into a crater at the South Pole and then use propulsion to hop back out. So I'm really glad to see this on a much larger scale. And I think Blue Origin's original concept was to support that as well, with the Blue Moon lander. So I'm glad to see this being scaled up.
Oh, thanks, Clayton. Right on. Yeah, I'm gonna see what else is in here. Concept of operations. Scope of the mission is to demonstrate aggregation of HLS elements, HLS dock and transfer crew to HLS, lunar surface landing near the South Pole, lunar EVA, return of crew and materials. Yeah, okay. I'm going through this real quick. Definitions for the constituents of HLS scope is identified in the figure below or provided in the SOW. I'm skimming it, guys. Give me 1 second. Yeah, polar sortie mission, non-polar sortie mission, polar excursion, integrated cargo delivery mission, offloaded cargo delivery mission. Interesting that there's integrated cargo and offload cargo. Integrated cargo delivery mission. Oh, I don't know, like landing hab modules?
Reminds me of Boeing's lander concept, where their hab module was basically just the lower part of their spacecraft.
Yeah. You know what? For all the crap that proposal got, that wasn't a bad idea.
I completely agree. Yeah, it was just unfortunate that Boeing at the time did not follow through, and you can argue that they're still not following through. But
yeah. Landing modules are hard in Kerbal, so they're probably hard for real pig. Oh, yeah. Landers are insanely complicated, Pigzig. Like, seriously, one of the most... Actually, the bottleneck for the Apollo program was not the command service module or even the Saturn V. It was the lander. Fun fact. The lander was the bottleneck. Grumman was behind for the lander. That's why Apollo 8 didn't fly with one. True story. Yeah, landers are the hardest part, dude.
Indeed, and you brought that up. I don't remember off the top of my head, but I do remember that Northrop had to redesign, almost clean sheet, the lunar lander because something else in the design stack changed.
Yep.
So yeah, it was being developed for like 3 years, and then I don't remember what the trigger was, but then they had to clean sheet design in like 65 or something like that, and then in another 3 to 4 years they were well, in another couple of years, they were already flying it. So yeah, that had to be stressful. But yeah, the problem with landers, at least in the Apollo architecture, was things drove the design of the lander. The lander was not able to drive other aspects of the design, which just makes it harder.
Yeah. If you're going to land on the moon, designing it around the lander that lands on the moon seems to be probably a smart idea. I mean, freaking ascent module. The ascent module, they had to cut the mass out of that ascent module so much that the ascent module for Apollo is basically an aluminum balloon. It's not very thick. You could punch a hole right through it.
Mm-hmm. Yeah, you can see like the pictures of the limb on the surface. Like it looks like cardboard paper.
Yeah, that's not too far off, right?
Indeed, yeah. You could actually move the entire. I don't remember what material it was. I don't think it was just sheet metal, but I remember astronauts. Oh, it is? Okay, yeah, aluminum. Like I remember some astronauts account where they were scared to even like lean against the wall because it would bow out.
yeah, I wouldn't. Yeah, no. Look, I mean, guys, look at it. It looks crumply because it is crumply. Yeah. Also, a lot of people don't know that this thing is asymmetric. I know it's really easy to look at it, but it's asymmetric. They had a non-gimbalable motor. They had to use the RCS to keep it on an even keel on the way up because you don't have the mass to be able to make it symmetric. The LEM is basically a pressure vessel with a bunch of fuel tanks and a rocket motor attached to the side. That's it. And then antennas and RCS. That's it. The ascent module is very, very, very complicated for what it is. The windows are probably stronger than the wall. I believe, yeah. Yeah. Yep, Allegard, yeah, that's purpose design. That's about as Spartan of a design as you can get. Is it true that it couldn't withstand its own weight on Earth, and that its walls were only as thick as a couple of sheets of aluminum foil? That's correct, Alleviate. It can stand up here. It can stand up here. Yeah, it can. It'll a little bit, but it can stand up here. Yeah, not very well. Yeah, I mean, the thing was designed to operate on the moon, dudes. That's it. Like, designed to operate on the moon. It's not that it looks very foreign to us, right?
Discovery, go at throttle up.
Because this vehicle was designed for 1/6 gravity. Also, this is literally a mobile launch platform. Think about it. It's a mobile launch platform. Yeah, you see the fuel tanks off to the side there. The computer is that's what this back piece is. That's all the computer back there. Crazy, right? Actually, Raga, something I didn't know. They hung this thing inside of the Saturn V. The LEM is hanging from the landing legs.
Mm-hmm.
See that little latch right there, fellas? The latch that's on all four posts? Yeah, that was the payload attachment fitting. There's 4 of them, and it kind of was hanging inside of the Saturn V. Really, really interesting. But when you think about it, that actually makes a lot of sense. You're not going to hang it from the ascent module. That thing's as delicate as tinfoil.
Yeah, build it into the landing gear because your landing gear has dampers. It's meant to flex, which is perfect for launch loads. And then they're also the strongest part of the vehicle because they're meant to, well, have the entire thing sitting on it. So best part is no part, right? Double it up, dual use.
Yep, that's genius. Genius. Oh, man, it's so smart. Is the moon the only place that humans launch a rocket from besides Earth? The moon is the only place we've launched a crew-rated rocket from besides Earth? Yeah. Actually, it might just be rockets in general. I don't think we've launched anything off of another planet.
Well, hopefully in 2026, that'll be Mars, if the sample return mission gets underway.
Yep, that's right. That's right. Soon, man. I'm going to have to go over the broad agency announcement stuff. I just want to see if they added anything different, but I don't think there's any particular new information there. Let me see what else we have. So Rocket Lab tomorrow is going to do a webcast for their investors. Look at this. Tomorrow at 1:30. Yes, we're going to be here for that. NASA will do a webcast, or not NASA, Rocket Lab will do a webcast for Investor Day and neutron development. Oh, we got a neutron update tomorrow. We launched up from a meteor. Okay, yeah. Cool. All right, what else? Oh yeah, Rocky Guy, check this out, dude. This one's funny. Wait, hold on, back to the other scene. We are pleased to announce Spin Launch has successfully closed a $71 million Series B funding round. The funds will be used to further the development and commercialization of our low-cost, high-cadence mass accelerator launch system and comprehensive satellite production line. Well,
I feel like we could make a lot of money being advisors to investors in the space market.
You want to do that? Aviation Investing Consulting Group? We should do that. Let's do that.
I think we could definitely do that.
All right.
Yeah, so I saw this today, and I want to see where they take it, because spin launch as a concept makes a lot of sense when you're talking about mega constellations over a certain size, and that all depends on your operating cost for that, right?
Yep.
Because it does, if using spin launch is only, let's go to the extreme, $100 a launch, and you need to make 1,000 of them, then that's great, because the off chance of that is then you would have to buy, let's say 5 Falcon 9s, which will put you over the, $500 million mark or something like that, right? Mm-hmm. So, I mean, if you're talking about very large mega constellations, it makes sense. But we're not seeing that demand yet. We're seeing mega constellations, sure, but not any that don't have a launch provider.
Mm-hmm.
So yeah, I don't know where their market demand is going to come from in the short term.
Do you think they would do an in-house mega constellation?
I mean, they could. I would be interested in seeing what service they're bringing. Because, with, you could say global internet access, but that's already being tailored to a lot, and they're already really far behind. If you're talking about Earth observation, they're going to be competing with Planet, Google, and Black Sky. I mean, yeah, I'd be interested to see what service they would provide if they plan on doing their own.
Yeah. So I got this is the concept video, fellas. If you guys are wondering what spin launch is going to do, basically the name implies what they're going to do. They have a carbon fiber sheath second stage. So it's a second stage that's inside of a carbon fiber fairing, and they have hydrodynamic radial bearing and dual AC motors there. And that basically they're going to spin that second stage inside of a carbon fiber fairing and frisbee this thing out. Yeah, I mean, Rocket, they clearly have some kind of business plan that's enough to raise $71 million in Series B funding. I've seen their facilities in Long Beach. They definitely have some backing behind it.
Yeah, and this is something that I guess I just don't understand from an investor's point of view yet. Like, so working in the industry, you hear about all the time these different commercial companies getting quite literally insane amounts of money for something that doesn't seem to be a payoff in any time frame.
Yep.
Like, I know of a company that just got like $100 million for developing like habitat modules on the surface of the moon, which is great. But guess what? We're not going anywhere near with what the size they're trying to actually build to for probably the next 10 years. So it's great to hedge your bets in that case, but what's going to be the return on investment, and how is that demand going to increase when your only customer is NASA in the foreseeable future? So, I don't know. I'm not an investor. I know it's good to invest in these things, and I'm excited for it, but it's not my money.
Yeah, that's true. Like, dude, this can't help but make me think, like, we could start it's the dream, dude. It's the dream that we've talked about. A small sat SSTO, a fully reusable small sat SSTO. So, like, I'm talking a venture star that's like maybe the size of a small automobile that could put a shoebox size satellite up in and come back down. If they could get investment for frisbeeing a freaking second stage, maybe we should go and do that.
I like it for sure. And I don't remember if you saw it when you rated last night, but did you see Hyperspace from France?
No. I went and hung out with Brimo.
Yeah. So they're a startup company, private in France, and they're developing hybrid aerospike engines. This is cool. For a single stage to orbit small sat launcher. They're French. The name of that system is the Baguette 1.
What's the name of this company?
Hyperspace, HYPR space.
Are they the ones that posted that aerospike with the nitrous tank next to it?
The very one, yeah. They just won like $1.1 million.
Huh. I'm trying to find it. Anybody got a link? It's HYPR?
I think so, yeah. HYPRspace.com. I think so. Oh, there's a dash in between hyper and space. So it's HYPR-space.com.
I don't know. You got it. All right. Theory. It's what I call the Apple effect. Back in the day, everyone laughed at them and their concepts of home computers. How many wish they had been original investors? Yeah, I guess. I mean, they're developing a spike motor. Oh my gosh. It's literally called Baguette 1.
Mm-hmm. Yeah, and I don't remember what they're targeting, like 100 kilograms or something like that. About 300, yeah. But yeah, it's a hybrid motor, which is kind of interesting. I feel like that's the wrong move because hybrid has less performance than conventional. So any performance gain you were hoping to get out of your aerospike nozzle, you're now losing that by using worse propellants. But each their own.
Say that part again. Sorry, I was just looking up the picture.
Oh, so I was saying, like, so they're developing an aerospike, right? Because they want to achieve better performance out of their engine being a single stage to orbit, right?
Mm-hmm.
But instead of going with a good specific impulse fuel like Methalox or even Carolox or something, they're using hybrid. So a solid fuel, and they're using LOX as their oxidizer, which is worse performing than any other propellant. So it's like you're developing something that you want to be an SSTO, building an aerospike for it, and then using a worse performing propellant. So why?
Safety first, or maybe heat shield between the nitrous tank and the flaming bit. Could be a nitrogen tank, fellas. So this is a solid. It's a hybrid solid aerospike. Yeah, that makes no sense. Okay. Huh. I mean, it looks like it's working well.
They're getting flames out of the flamey bit.
Yeah. All right. Yeah. Oh, it's working. They're named after this. I know what a freaking baguette is, man. I know what a baguette is, dude. I love you, bud, but I know what French bread is. Damn it. All you just did was just make me hungry by linking pictures of freaking baguettes.
I hope their name of their aerospike is something like brie or something like that. So you can have baguette and brie, or I don't know what typically goes well with baguettes. What's a staple combination in France?
Wine.
The croissant.
Croissant. Yes, a croissant on baguette one. Ha 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 ha.
That should be the name of their, I don't know, their kick stage, the croissant. So you have the croissant, you have the baguette, and you have the brie, garlic butter. People saying, who knows? Yeah, just all of their names should be just, dripping with French culture.
Okay. The garlic butter is the RCS. Oh, now I'm getting hungry. Stop it. Yeah. Why do you think they're using solid aerospike with nitrous? Why would you do that with this type of application?
If you want my take, I will just straight up say it's for investors. Investors want to see differentiation, right? There's
Okay.
As of what was the number? There's like God, I don't remember what the number was. It's like in 2019 there were like 2,500 startup companies working on small launch vehicles alone. So you have to try and figure out a way to differentiate yourself.
Yeah.
So those differentiators might not be the most optimal, but if it gets you funding, then there you go, right?
Yeah. Yeah, they want to answer the question, what makes you different, Pete? Yeah. Okay. Yeah, that makes sense. Pete, do you think a small sat SSTO, a fully reusable small sat SSTO would be enough to pique investors' interest, perhaps? Burbaps? Maybe we use some off-the-shelf turbine machinery.
Now that you say that, just yesterday, Ursa Major tested their engines for their 5,000 pound force engine. So yeah, we could. I mean, what I really like about Ursa Major is they are basically trying to become an Aerojet Rocketdyne Junior, which I've never seen anybody else attempt. They're not focusing on any launch vehicles. They want to build the engines that can be used for everything. Mm-hmm. So it's kind of cool. So yeah, there you go. We can partner with them, and they're setting up to build a 200,000 pound force engine, which is about 890 kilonewtons, which is a Merlin 1D essentially. So Methalox too.
Wow. Hey, Hooded 15137. Pete, I don't know, man. I didn't see the business case for Astra. You're always in favor of new launch platforms, though. We'd need to aerospike it up, dude. Are you buying a J2? No. Is Rocket Guy in the space industry? If so, I'd be interested to know what he does. He works on rockets. It's in his name. Yeah.
Indeed. And to narrow that down a little bit, I work for a small startup company on satellite systems.
Yep. Hey, Predominant, what's going on? Show the investors as a pitch. Your Kerbal Creations as a pitch. No one else is doing that. You know what, man? In this day and age, you never know. They might go for it. So, Ursa Major is supposed to be. They're not. You said they're not building a launch vehicle. They're just building rocket engines, right?
I mean, they might have a launch vehicle plan, but no, they're, from what I've seen, they don't have anything in the pipeline other than building out these engines for the industry.
Interesting. You said this is Merlin 1D powerful, this guy right here?
No, not that one. This is their 5,000 pound force engine, which is about 20 kilonewtons.
Yeah, okay, so it's a little guy.
But they're in development with a Methalox 200,000 pound force engine, which is around 890 kilonewtons, which is basically Merlin 1D.
Yeah. Methane Merlin 1D. That's interesting that you're seeing a cottage industry build up like this, dude. That's actually really
truly
cool. I mean, Firefly is trying to do the same thing. They're trying to come up with standardization. That's their business case, right? Like, that's actually not a bad idea.
Yeah, I mean, I think it's really cool to see the entire aerospace commercial market go the way that it is, right? You can really see it when you take like a 10,000-foot view, all of the different circles of interest, right? Like you have, for instance, driven by NASA, everything around the moon. So you have like Astrobotics, you used to have Mast, and you have Intuitive Machines, right? You have all the Commercial Lunar Payload Services contract. You have Sierra. You have everything from small players to large players. And then when you kind of zoom out from that point and look over, to the left, so to speak, you have the small sat space, which is, your Electron, your Astra, your Virgin Orbit, your Firefly Alpha, right? ABL Space Systems is set to launch this upcoming weekend. You have a lot of those up and coming sectors. And then, of course, now you're looking in a completely opposite direction, and you have your suborbital flights for people, right? So now you have Blue Origin, you have Virgin Galactic, and you have Copenhagen Suborbital, and all these other ones, internationally speaking. It's really cool to see. Yeah, exactly. Yeah. It's really cool to see where the industry has just taken the open room that NASA and others have given and making it their own.
Yeah, it's pretty nuts. RJ, you've seen a lot of small sat launchers, but how many developers are there for small sats? Is Rocket Guy's company a standalone idea? Actually, yeah. I mean, Rocket, what you're doing is kind of definitely different than most that I've seen, at least.
Yeah, indeed. We are working on our first mission. Can't say really any more than that.
Yep.
But yeah, we hope to be a satellite manufacturer. In terms of others involved, most of them are your big players like Maxar, Millennium Space, which is a Boeing company.
Yep.
Those are the ones that make like your geostationary, and those are the ones that also typically make some of the higher end, like larger player satellites for telecommunications. But then you have smaller startup companies like Blue Canyon Technologies, who is kind of like almost like your Airbus, so to speak, with the aviation industry. They're really clean design. They're a little bit on the expensive side, but they've been around forever and they do a really good job. But then you also have Airbus. Airbus also develops. They're the ones that are manufacturing things for OneWeb after OneWeb stopped building things in house. Yeah, so I mean, you do have a lot of players. You have York Satellite Systems, I think. York Space is another big mega constellation satellite provider. Yeah, there's a lot of commercial sector interest in satellite development. But what's really, in my opinion, the bigger view to start seeing is that there is a massive push within the industry for what's known as OSAM or ISAM, which is on orbit servicing, assembly and manufacturing, or the I is in space servicing, assembly and manufacturing. And so that's basically what Northrop Grumman has demonstrated with their MEV, their mission extension vehicle, right? Actually going to a satellite that's either defunct or near end of life and attaching to it, either becoming part of its control system, or what the DoD and NASA really want to do is to completely change out parts. Open up a satellite, swap out a degraded battery or solar array, change out the entire payload if you want. You can completely redefine a mission of a satellite that's already in orbit without having to dedicate a launch necessarily to get a new mission going.
Ooh, small stat SSTO would be very favorable for something like that. That's all I'm saying, man. What? Huh? Pete, okay, so yeah, I wanted to see what Pete said. What do you say? So there are many similarities with New Space and the dot-com revolution. You had your old ancient telecom companies that fought innovation just like in aerospace. Now we're starting to see the consolidation phase with Maston getting acquired. Yeah, I think we're going to see a lot of M&A activity over the next 5 to 10 years. I also remind people that SpaceX may be on top right now, but so is Yahoo and AOL at one time. It can change very quickly. I wouldn't bet against Elon, though, yet. Yeah, I'm kind of with you on that one. They're going to do surgery on the satellite. Blue Flare, yeah. Modular satellites, dude. You know how I always rattle off these ideas about how making like a modular climate satellite constellation that we can constantly upgrade to change with the needs of what we need to monitor Earth's climate? And then having like NASA operate the constellation, and then having like commercial crew vehicles like Dream Chaser or Starliner or whatever go out and be able to service and change parts on these satellites. You know how I always talk about that? There you go. There's a reason why I mention stuff like this, is because there's a huge need for building Lego kit satellites. Yeah, there's a huge need for that right now. Oh yeah, big time. Also, they did surgery on a grape satellite, and they did helicopter on Mars as well. That thing still works, by the way. Can you believe that? Ingenuity's still flying? That's like, all right. Okay.
I mean, if Spirit and Opportunity were any indication, yes, I definitely am not surprised Ingenuity is still flying.
Yeah, what a beast. Can JPL make them right or what? They broke the mold with that thing.
Indeed. Or, so here's the thing, right? Does JPL just make really, really robust systems, or does JPL and NASA just set the bar so low?
I think their life expectancy of a mission is based off of the worst case scenario. So when it overperforms, you can't complain, right?
Exactly. Or both. Exactly, Creeper.
Everybody's launching sats. What we need is someone to start bringing down the old ones. Well, that has to do with modular satellites, Four Fingers. That has to do with what we're talking about. Bringing the satellites down. Attaching a deorbit module. That technically qualifies as in-space satellite operations, right, Rugged? That's ISAM, is that not?
Yeah, so what you're going to see is the ELSA D mission is currently underway by Astroscale. They are paving a way for how to deorbit already in orbit satellites. That's the industry. That's going to be the next big boom, is OSAM and ISAM. How do you not only repair and upgrade satellites that are in orbit, but possibly more importantly, how are you going to go and clean up the geostationary graveyard, or how are you going to go and clean up sun-synchronous orbit, which is already seeing problems? So, there's a lot of companies working on that problem, mine included.
Yeah. Do you think it would be better to recycle those satellites? That, like, dude, so fellas, there is probably close to, in decrepit satellites, Rocket, would you say like $1 billion worth of hardware up there? Easily. It's got to be up there. Like, do you think it'd be better to take those satellites and recycle them on orbit, or just deorbit them?
It's a good question. So I think in the short term, just go ahead and deorbit, because we don't have the technology that can just ingest a satellite and melt it down or take it apart or whatever, right? That's coming, but that's probably a 10, 15-year goal before we can really do that. And then also you have the problem with logistics, right? Satellites are in every orbit from zero inclination at 100 kilometers all the way up to, retrograde orbits, or all the way out to geostationary. So you'd have to set up strategic outposts to be able to service different orbits, right? Or you'd have to have a heck of a logistics vehicle to go and grab one and bring it back. So short term, I think the answer is just deorbit it. I mean, you're not going to get... They're also made with such different materials. Most of the structure is usually aluminum, but then you also have honeycomb paneling, which is a little weird to work with and melt down. So it's a lot of issues to overcome to actually recycle.
Mm-hmm. Yeah. Okay. Cool. Good to know. So long-term goal. Yep.
Yeah, I mean, if you're talking about deorbit, but save them, that also has its issues in terms of how do you now integrate a heat shield or something like that to bring it down safely. There's another company working on that. I think they're NovaWorks, if I remember off the top of my head.
Yeah.
And then they also have their RED 25 RED. I think it stands for like reentry device or something like that. That is designed specifically to do that, but that's still a little ways away. And then you now have to have a vehicle that goes up there and attaches it, right, to bring it down. So another complex mission.
Yep. And then Razmi in chat brought up a really good point. Who's going to pay for all that? It's got to be cleanup initiatives. Yeah, that's that could potentially be very profitable if you figure out a way to either A, extend the life of satellites, or B, figure out a very inexpensive way to get them deorbited and get them out of the way. There's a lot of junk up there, guys. There's a lot of crap.
And what's kind of interesting is that coincides with the newest. I remember you covering for Space News a couple weeks back, right? Is the change in regulations by the FAA to now you have to deorbit your small sats within 6 years when it used to be 25 years.
Yeah, they mess with the EOL on space debris.
Exactly, and so that can be a driving factor, is those regulations, because anything above roughly 500 kilometers circular orbit it takes about 6 to 7 years already to deorbit naturally. So if you have anything higher than that, you're going to be hurting. You're going to start needing actual active systems to deploy to help increase your drag, or all these other things, technologies that are currently being developed. So regulations like that could drive the market for sure.
Yeah. Satellite version of bottle deposit. Yeah, basically. Back when we started to do regular spaceflight, did we not think that maybe having lots of space junk on orbit would be bad, and maybe should have measures in place to deorbit them? Uncapping, long story short, there's more people launching things into space, and up until, I don't know, last 10, 15 years, it wasn't really a problem because there weren't many tenants up there. Now there's a lot more tenants. There's a lot more tenants, a lot more satellites.
Yeah, exactly.
So that's, guys, a lot of people give me crap for defending this when it was a thing, but that's part of the reason why Space Force is a thing. Space Force isn't really necessarily like a military force in space, because the way war is fought in space is not like shooting guns and stuff. That's not how you do that. It's really more of an intelligence game. Knowing where the other guy's satellites are, knowing where debris is to protect your own satellites. It's part of the reason why Space Force exists. It's a drastic expansion of the Air Force Space and Missile Systems division, I guess is what it was called. Yeah, it's expanding that into its own department that serves under the Air Force. So the Space Force to the Air Force is what like the Marine Corps is to the Navy. It's a specialized version of a much bigger encompassing thing. But yeah, they expanded the Space Force for that exact reason, because there's a lot of crap up there. Not just our stuff. There's the Russian stuff. There's the Chinese stuff. There's the European stuff. Basically, more tenants in space, more crap's up there. So basically, they didn't do much about it because they didn't launch that much stuff into space. 10 years ago, you'd be lucky to see one Atlas V launch every couple of months. Yeah, and then it's just Atlas V, Delta every once in a while, and Soyuz, and then maybe that Falcon rocket would have a chance at landing on something maybe in the future. Like, yeah, we're launching way more stuff. Like, dude, we're getting a Starlink launch every week. Every week! Isn't that crazy?
Yeah, you definitely hit the nail on the head. I mean, if you look back at the historic numbers of space launches, right, they were a very large majority from the 50s all the way up until 2012 was all government operated, where you were only launching, like you said, a few times a year, and those launches would only really, at the time, we were having large satellites like going to geostationary orbit and whatnot. So you basically had one launch dedicated to one satellite.
Yep.
Right around 2011, 2012, you had the introduction of the CubeSat. Now, the CubeSat is now basically transforming the entire industry away from those massive, large one-off systems to much smaller systems, roughly the size of a shoebox, or even like a desktop computer. And so now why that's important is because that drives the cost, because now you can ride share on things like SpaceX, and you can share the cost between a lot of different launch opportunities. And so now, instead of spending, I don't know, $100 million to launch one satellite, you can now spend $1 million to launch a satellite roughly, 30 pounds, 60 kilograms, whatever it ends up being, right? That's where the entire commercial market started entering, because now you had, believe it or not, this was all spurred by academic research. CubeSats came around from Polytechnic, California Polytechnic, and Stanford. They developed the CubeSat standard to get students involved in developing small sats, and it had to be small because, well, universities don't have a lot of cash flow, right, to spend on launches. And so then that basically they had a couple of launches in 2012. Like I think you can count on like two hands how many CubeSats launched in 2012, and then 2013, 2014, hundreds of CubeSats. Like it hit the market, and the entire industry ran with it. So, yeah, and to also put into perspective with some data before Starlink came online. Before Starlink came online, like before they were starting to launch every basically week now. I think this was like 2018, 2017 figure, if I remember correctly. Something on the order of like 3,600 satellites were in low Earth orbit. And what's interesting is out of that 3,600 satellites, only 30% or 40% of them were actually active, which means that all the other satellites out of them were defunct or no longer in operation. And so just within the last 6 years from that point, we're now approaching 2,000 Starlink satellites alone, on top of the now thousands of CubeSats and small sats that are dominating the market launching now every year. So, yeah. The growth in the industry just
Insane.
was not foreseen at any point in time until literally the last decade.
Yeah, it's absurd how, like, guys, this is what I mean. 10 years ago, it sucked. It sucked being a space fan. Nobody was launching anything, and yeah, it's not fun. And then the space shuttle went out, and then Constellation went out, and it was dude, it was terrible. It was freaking terrible. But yeah, that got turned around a lot faster than I thought it would. Yeah. Modular stations are definitely coming. Ugh. Modular stations are definitely coming. They're talking here. Hold on. Somebody. There's commercial low Earth orbit destinations. There's I think Blue released some stuff about orbital reef. Yeah, today. Here. Yeah, it's not too much. It's not too big of a deal, but orbital reef will be featured in Helios, a sci-fi movie depicting the future of life in space. Yeah, see, they're really. Yeah.
I really like that concept.
Yeah, orbital reef is pretty damn smart. The orbital reef is a concept from Blue, Sierra, Boeing, Redwire, Genesis, and ASU to build basically hotels. Well, not a hotel. It's actually it's mixed use. It is a mixed use space station, commercial, residential, industrial. It is like those office buildings that you see that are mixed use. That's basically what this is. But actually, there's another thing going around here. Speaking of low Earth orbit destinations. Hang on. Raga, did you hear that Hilton signed a deal with Lockheed Martin?
I did not. When?
All right, so check this out. This was the other day. Hilton, the hotel.
Paris Hilton?
Yeah, exactly. Yes, believe it or not.
Going to space?
Yep. Hilton is to design astronaut suites facilities for Voyager's private space station, Starlab. Yeah. Hilton is on board with Voyager Space and Lockheed Martin to build space hotel rooms. Yeah. This is an article from Mike Sheets over on CNBC, which is just absolutely absurd.
Discovery, go at throttle up.
I'd like to take the presidential penthouse, please.
Yeah, me too. Probably a great view. Smokey! 16 months. Thanks, man.
It's interesting.
Yeah, that's really freaking cool. It seems like Lockheed is going with some type of expandable module, too. Show up and your room's already booked. Do they have room service? Yeah?
Well, with spin launch, there you go. Instantaneous launch opportunity with spin launch.
Dude, that is brilliant. That's freaking brilliant. Oh my goodness. You could DoorDash some pizza.
By the time they got to your room, it would probably be soup because of the G's from that. But I mean, yeah, there you go, right?
That's awesome. Doesn't Bigelow have stock in the hotel business? Bigelow is not a thing no more.
Is that official? Or are they officially like gone, or are they still like the one employee company?
They're the one employee company, but they returned the TransHab patents back to NASA. So.
Oh, that's right. I remember that. Yeah.
Yeah. So basically, you could warn them if you spoke Wachutu. Okanabavusu, Mufasa.
Yeah, it's amazing.
Yep.
Like bringing that up. Like I wish well, maybe not, but like I wish I could see the inner workings of Bigelow at the time as to like what happened to them, because they had the NASA contract, right? And it's almost like the exact same thing that happened to Maston, right? They had a NASA contract and then like went bankrupt. So I just wish I knew why. I guess they didn't have any backers for their space station technology at the time, because they had launched already a free flyer and they had a NASA contract. So
and they had Beam.
Exactly, that's true.
Module at the space station.
Yeah, it's interesting.
At what point does it become useless saving a satellite? How many times can you send up a service? Goalie, I can answer that one. It really depends on how modular you made the architecture. What's your bottleneck? What does your satellite do?
Yeah, indeed. And man, that question really has a lot of different variables and inputs to consider, because, you know, just one satellite doesn't really make that much sense unless you plan on basically completely retrofitting a brand new vehicle in space using the old vehicle, right? Like the inputs that make servicing efficient and cost effective is, one, either changing out very expensive subsystems to keep the overall satellite surviving, or sorry, strike that, reverse it, changing out very cheap subsystems that have a short lifespan to make the overall larger expensive system with more expensive subsystems running longer, or take advantage of economies of scale. If you can service a satellite that is in a popular orbit, say sun synchronous orbit, now you can service maybe 10 vehicles. So if you go around servicing, changing out the solar arrays on 10 different vehicles and expanding 10 or extending the life of 10 different vehicles all off of one launch, that's fantastic. So there's a lot of things that you kind of have to take into account to the point where servicing actually becomes viable. And if you can refuel them while you're at it, that could be really good.
Beam still there, or did they detach it? No, they transferred operations to NASA, to Johnson Space Center, Pythos. Yeah. They basically renationalized all of Bigelow's patents, but they were NASA patents to begin with. Yeah, Bigelow expandable modules they were a patent that found its way to the public based off of what was called TransHab, which was a NASA design. In the same way that Dream Chaser started as an HL-20, it was a NASA design. It was an in-house design that found its way to a small business. NASA has plenty of incentives to take these ideas and transfer them to small business. They have tons of small business initiatives everywhere. If they start making satellites as modular as, say, a PC case with its case, you could start swapping parts out. And if they start recycling the used parts in space and print new stuff from old, yeah, Tessa, how easy is it to take a leak down here? How easy is it to take a leak up in space? Everything is way more complicated, dude. It's not just about making the satellite modular. How are you gonna swap out parts? You gonna send a person up there? I saw it, Snackless. It looks great, dude.
Yeah, the reason why in-space servicing is such a big problem, why the DoD and NASA are throwing money at it, is because you have to think about it from both sides, right? From the servicing side as well as the satellite side. And unfortunately, right now, where the money's going is really on the servicing vehicle, and they're not really looking at the proactive approach of modular satellite systems that can take advantage of servicing in the future. So if you look at it from the problem of the servicing agent, okay, well, every satellite today is basically not designed to be serviced. So that means you need multiple end effectors. You need systems that can literally unscrew bolts. You need a system that can cut through mylar. You need systems that might have to cut through metal, depending on what kind of satellite system you're operating on. You need vision systems. You need, I mean, there's a lot. You also need dedicated ground time in order to actually command your vehicle, so that limits your overall orbital coverage. There's a lot of different problems to solve just on the servicing side. And then if you look at it from the satellite side, if you actually want to make a satellite capable of being serviced, like, you know, more easily, now you have to talk about how do you have a quick disconnect system that allows you to just unplug a module and plug a new one in. That comes in from the software side, and software for satellite systems, a nightmare, because if any one thing goes wrong, you know, good luck. That's why NASA's still using technology, you know, boards and things that have been down here on the ground for a decade already. They're generations behind because they know it works, and they've developed systems that work for it. The change process for any satellite system, any new technology in the aerospace industry, that's kind of what has to change first if we want to adopt, you know, more expansion in space.
Yeah, it's not just as simple as just, oh, I'm going to take this out, put this part in. That's a lot more complicated than you might think. And Rocky, thank you for the insight, man. That's super, super, super useful. That's smart, dude. You know, like when I talk about stuff, I generally just talk about hardware, but you know, that's not even including software sides of things, dude.
It's the stuff that keeps me up at night.
Yeah, indeed. Duty. All right. So let's switch gears a little bit. And I have some footage for you guys that you might want to see. Yeah, the shuttle was supposed to fill that niche. I know.
Indeed. And I will take that as a cue to head out and get some dinner, because I just got home basically when I got on. So.
Oh, all right, man. Go.
Thank you so much for having me,
dude. Indeed. Thanks for coming on.
Yeah, very much appreciate it. Love talking space. I'll be in chat shortly.
All right, my brother. Go get some food.
All right, later.
See you, buddy. And guys, that was my buddy Rocket Guy. Rocket Guy is a rocket guy that works in the industry. We'll just leave it at that. Works in the aerospace industry, and he also streams on Twitch. Thanks for coming on, man. Yeah. We should get the band back together. You know what I'm saying? Come on, Synergy. There we go. I just got to switch scenes here. And this is the next thing that I wanted to show you guys. Let's go over here. Oh, headphone users, by the way. This is coming from Relativity. Headphone users. Yeah, you might want to.
Discovery, go at throttle up.
Black Horse 4, Mr. Rocket Guy. Go subscribe to his channel too, Black Horse. Remember? Nice Bruins shirt. Oh. Yeah, Paul, there's a reason why I got my Bruins shirt on today. That's because of what's going on right there. I don't know why it's chroming out gold, but hey, whatever. I can once again wear this shirt, and it's not weird. Anyway, headphone users. Sorry, I was on it. Nice. Wow. Respect for Char as a player, but let's go Blues. Do not say that sacrilege in here, I swear to God. Hype's on. Okay. So, this is Relativity. Relativity Aerospace is testing their Terran 1 rocket. That's their Terran 1 rocket first stage. That is the launch pad for it, but it's also serving as the test stand. I don't know if you knew that. Guys, that thing is 3D printed. The entire rocket is 3D printed. The only things that really aren't 3D printed on that thing is like a couple of bolts, some nuts, maybe some fuel lines here and there. The tank structure of the vehicle is entirely 3D printed. And the engine, all the main components of the engines, all 3D printed. That's pretty freaking cool, man. Yeah. Relativity is trying to, so we were talking about with Rocket, we were talking about different things that investors have to, like, you show the investors, like, oh, this is how we're going to revolutionize this. Like a Keralox Aerospike, right? That we saw with Baguette 1, with hyperspace. Relativity is kind of what they're trying to, the way they're going about it is trying to 3D print most of the rocket. They're the only people I know that are 3D printing their tanks. Once again, that whole thing right there, and this is at LC-16, Complex 16 at Cape Canaveral Space Force Station. That whole thing is printed right there. They're the only ones that are doing that. And then with their 3D printed rockets, they're trying to work on orbit 3D printing and manufacturing from there. Yeah, Galat, that's right. Can you believe that? That's 3D printed, man. That's pretty freaking good. Yeah, I know, Metroid, right? You want to see the jig? You want to see the jig make the freaking thing? Watch this. Here. That's awesome. Here, they have footage of it around here somewhere. Huh. Well, there's the flame trench. Yeah, look at that. Look at that. That is a 3D printed bulkhead ISO grid. That is not easy to do.
Go at throttle up.
How long do we have a rocket called the Pillar of Autumn? I don't want a rocket called Pillar of Autumn, Pythos. I want a spaceship called the Pillar of Autumn. Hey, Force. Thanks for the sub, dude. Yeah, that is a 3D printed ISO grid. Yeah, not an ISO, ortho grid. Yeah, excuse me. Yeah, that's oh, hello. Look, even the rocket engine, 3D printed. Except for the fuel lines and a couple of fittings, but most of it is 3D printed, which is just unbelievable. I'm trying to see if I can get you guys a picture of their 3D printing jig working. Let's just, we'll go over here.
Discovery, go at throttle up.
I think it was right up at the top. That's the Veritasium vid. Yeah, but Veritasium has their footage, their stock footage. Look, did you see that? Did you see that thing? Look at that. Can you believe that? Now, like, take Starship, for instance. This would be, like, a good amount of different components. Oh, thanks, Aquawex. Yeah, there we go. We'll get off the Veritasium video and go over here. Veritasium's an amazing YouTuber, by the way. Why print tankage instead of a more efficient manufacturer? More efficient manufacturer build. This is the more efficient way of doing it. It doesn't take them that long. They can literally print an entire stack. So LOX, common bulkhead, kerosene, or I think they're using methane. I'm not sure. So LOX and methane tanks, they could print it in a couple of days. That's way faster than friction stir welding, which is kind of like industry. So a milled aluminum ortho grid with friction stir welding is kind of the norm. They can crank out tanks very, very fast, dude. You thought it was like 60 days? Maybe, what did I say, 6? Maybe it's a little longer than that, but even 60 days for tankage is... That's pretty fast, man. That's really quick.
additive manufacturing and relativity space has really enabled us to be iterative in our processes. We can print any geometry with shapes that incorporate what usually would take multiple different parts and components. And so we're able to print something, test it, and then go change the design based on testing results. And so that process is extremely iterative and also low cost. And that is really the ace in the sleeve when it comes to additive manufacturing, and specifically here at Relativity Space.
The printing process here at Relativity has a lot of moving parts. Basically what we do is we start off with this empty table right here. We set plates on them, and then we prep to start printing, check the parameters, get ready to start up, set up our walkies, and get moving. And then after that, the robot's pretty much taken over and starts laying beads so that each cell is printing a separate section of the rocket.
What makes our printer autonomous is the sensors that we integrate onto the robot. Depending on like the section we are, the printer is going to act a little bit different. So we have to make our control loops to keep up with that. And that's like the key importance of making our robots autonomous.
To build Terran 1 and ultimately Terran R takes a unified effort amongst all the teams in additive development. That includes the 3D printing technicians, our software engineers, our robotics engineers, our mechanical engineers, our manufacturing engineers, and our weld engineers, along with all of our materials engineers in the materials lab, and also our world-class non-destructive evaluation team. So all these teams come together to bring all their different skills and attributes to build a additively manufactured orbital class launch vehicle.
So, stress test, come on, mouse. Stress test, you're asking if the rockets are reusable. The Terran 1 rocket is not reusable, but Relativity has planned, well, here. You know, Susie is kind of the hotness right now from, from Ariane Space, but Relativity released this video about a little over a year ago. Look at this. No, that's not enough delta V on those ones, Doc Flynn. Yeah, so they have a roadmap to reusability. Yeah, right, Bill. Yeah. Pretty cool, huh? The future is now, old man. Also, here, watch this. This was from them from the other day. Ready? That's nice. If the printer messes up, is that part junk or can they fix it? I'd assume they have the problems that are kind of come with 3D printing. Yeah, if you don't level the plate correctly in any 3D printing gun, yeah, you know what I'm talking about. But I don't know, dude. Who knows? I'm not Tim Ellis. You're gonna have to ask him. He's also a StarCraft fan, which is why the rocket is called Terran 1 and Terran R. Yeah. Yeah. Are we thinking maybe SpaceX was onto something with their rocket design? Kind of looks like we're seeing more and more things that look like ITS and Starship. Yeah. How will they combat the challenge of printing in microgravity? With science. With science and engineering. I have no idea. Yeah, that one, dude. If I knew that, they would. Then I'd be working for them. With science, engineering, and money. Yup. Science, engineering, and money. We're gonna science the snot out of this, but with money. I can't build it. Something's in the way. You want a piece of me, boy? Jacked up, good to go. Rock and roll. How do I get out of this chicken outfit? Need a light? Want to turn up the heat? Slam it. Sounds suspiciously like a Cave Johnson quote. Yep. I got the pics if you care to see. All right. Permit. Hell yeah, Keith. Link me, bruh. Push-pull semi with coaster look. Okay. That's not that. Okay. Yo! Dude. That's freaking metal. Seriously, that's a lot of metal in the picture. Look at that. Dude, an F40PH, my favorite. Oh. Oh, yeah. No, Keith, I'm nerding out. Yep. That's an F40PH. One of the most Chadliest locomotives ever devised by man. Oh, yeah. Yeah, that's cool. Coaster. Yeah, no, trains are amazing, dude. What a beast. Where the hell did you see this, man? That thing will never clear the launch tower. It was way too heavy. Yep. Yeah, you're not wrong. But a Dash 8? Man, screw Dash 8. F40PH, man. It's the best locomotive ever devised. Wait, what? Oh, gee. Okay, nope. No, get that off the screen, man. Damn. What the hell? Oh, no. Yeah, King, I try. The damn sign. How did I not see that? Oh my goodness. Oh, what's that about not doing the dramas in here? Wait, King, 300,000 people are arguing over drama and accident crimes are being done while here is just a normal. Oh yeah, I heard. Yeah, I heard about that. Yeah, we don't need to talk about that here. We could go back to looking at the stupid sign. How about we go back to look at that train on the truck with the Oh my god. Is it bad if this is less traumatic than what's going on, King? Is that bad? Like, is that bad? Like, I don't know what to say. Oh, it's like the DM2 boats all over again. Yep, it's the flotilla all over again. No, come on, Kyle, come on, man, dude. No drama here, please, man. Yeah, Loco, don't worry about it. Don't worry about it. It's that sign is a Rule 8 thing. Don't worry about it, man. Just enjoy the freaking locomotive. Keith, that's sick, dude. And that I'm serious. That locomotive is called an F40PH. It is a really it's electromotive division. They're really good locomotives. That thing is like the Toyota Hilux of train locomotives. If you catch my drift, you pick it up when I'm laying down. The thing is, it's such a good design. They don't break. They just don't. They don't freaking break. They just keep going. It was nuts driving by it. It was towering. Yep. Dude, that thing is the Toyota Hilux of locomotives. The thing is just, yeah, it's so well built. The F59PH is also nice. F59PH. Oh yeah, that's good too. Yeah, those are good. Those are good. That's the upgraded version. But then there's that. Yeah, it's F40PH and I suppose F59s too. They're the Energizer Bunny of freaking locos. They don't break. A lot of these F40PHs are still working. They're still in service. And they stopped making them 30 years ago. They're still in service. The MBTA in Boston still uses those things. They still look. We still have a fleet of the things, and they're like 40, 50 years old. They still work. They don't break. It's just a really, really good design. As long as you got plenty of diesel fuel. I mean, yeah, I guess. You have this running on spur lines here in Connecticut. AC 4400 CW is your favorite? That's a good locomotive. AC 6000s, I think, are better. But I figured out the story. It belongs in a museum. Cool. It's been 84 years. Keeps that going to a museum? San Diego commuter diesel moved to a museum. Oh, sick, man. That's wild. What museum is it going to? The newest piece of equipment for the Pacific Southwest Railway Museum. Recently retired coaster F40 PHM2C 2103. A heavy haul. Okay, during its move by Contractors Cargo Corporation, or Contractors Cargo Company, a heavy haul specialist based in Compton, California, with a history of including 19 moves involving all 6 NASA space A history including 19 moves involving all 6 NASA space shuttles. The locomotive is one of 5 built by Morrison Kunsid, mostly using EMD components. All 5 had been moved to Scrapper Coast Rail Services in Anaheim. But 2103 was returned to the San Diego area and loaded at National City, California for the final move to the Campo Museum. Ah, that's cool that they saved one. See, they're just retiring these things now. F40 PHM2C, that's an old locomotive. That's crazy, man. 2020, 40 months. Yep. A shop near me rebuilds those engines. They test them by hooking up to the grid and generating power. Yeah, F40PH is for a small locomotive like this, it makes 3,000 horsepower. 3,000 horse. Now, okay, guys, if you know anything about diesels, you know anything about diesel locomotives, horsepower is not the high figure with a diesel. What's the high figure with a diesel? Torque. If that motor is making 3,000 horsepower, think about how much torque it's making. Yep. That thing could literally power a small city. Yeah. Yep. Torque yeah. Locomotives can generate insane amounts of power. At least 2 torques. Yes, all the torques. But that's cool that they're saving that one. Really neat. That sign is ridiculous, man. I can't believe it. Wikipedia says it can run at 893 RPM. That's crazy, Aldezert, for how big that motor is. There's a reason why the MBTA still uses those things, dude. They're really, really well made. So, true story. A Canadian town was powered by 2 locomotives. They drove them on the road, not on rails. Yeah, locomotives are great power generators. Basically just a generator that's attached to some batteries. It's a hybrid. They're hybrids. They're good diesel hybrids, though. Cool seeing you back on. Keith, it's good to see you, man. Don't be a freaking stranger, man. Are you going to leave me here the vials of the internet all day? Damn, son. Also, I bought a shop. Yeah, I bought a shop. Just been busy? Yeah, that's all right, man. It's all right. Yeah, I bought a shop. Yeah. Yeah. With a house attached to it. Yeah. Yeah. Car shop? Yeah, I have. So I bought a house, dude, and it's got a 1,000 square foot garage attached to the back. Well, not attached to the back. There's a 1,000 square foot garage on the property. 30 by 40, 20-foot ceilings, dude. And it has a converted lean-to on the back, and that's where I'm streaming from. It's my office, man. I got the link if you'd like. I've actually heard that story, Bright. Yeah, it's pretty cool. The ship I was on in the Coast Guard had two Cooper Bessemer GND 8 4-cycle 8-cylinder diesel engines turning 2 generators for power. Yes. Sweet. House pics. Oh, I don't have any pictures of the house, but yeah, we'll I'll get pictures of the shop when I'm done with it. I'm working on it right now. That's what I do in the mornings. But yeah, I'll get you some pictures, dude. Yeah, yeah. Just peek in when you can. All right, guys. Do we want to do? There's an SLS test here. Hold on. Let me just get you the quick condensed news on what's going on with SLS. Friggin' awesome, indeed. Okay, so NASA is they're tracking their tanking test to make sure that the hydrogen on the TSMU is working correctly. The Artemis 1 cryogenic demonstration test is on track for Wednesday, September 21st, where the teams will be assessing 4 main objectives. NASA TV will provide live coverage with commentary beginning. No, they didn't roll it back. Oh, well, that's well, gotta be here for that. No, seriously. I'm gonna be here for that. I'll start up at 7 tomorrow. I don't want to miss that fueling test. So, guys, interestingly enough, the 27th is still on the menu. We haven't heard anything about the range package, or the package that was sent from NASA to the range about proving the operational life of the batteries for SLS's flight termination system. I start at 7, no big deal. Tuning, I actually, believe it or not, I've been getting up at 8 o'clock every day. And I start my day, I start my day at a normal time, and then I start streaming at 12. I'm not saying it's being to work at 7, but yeah, I've been actually getting up a lot earlier than I did when I lived in the apartment. What's the sum up of ISC? Oh, Luz, go watch the beginning of the Space News segment. Yeah, I had Rocket Guy actually come in and help me break down some of the concepts. It's really freaking cool. Is the 27th a long mission or a short mission? Long mission, good fella. Yeah. Interesting. I could have told you that they weren't going to do it on the 23rd. The reason why is because of the DART mission. DART's using the Deep Space Network. So they don't want to have any conflicts with using the dish because you don't want to lose the Orion spacecraft. Yeah. So all right, I'm going to be here for that coverage. But yeah, all this NASA stuff is happening either in the middle of my commutes or classes. Yep. Would the range ever launch SLS on the 2nd and Crew 5 on the 3rd? But yeah, I mean, if the corridors were open, great, sure, why not? Lose a spacecraft, you mean like Capstone? They didn't lose Capstone because the antennas weren't pointed at it, but yeah, I suppose. Dougie Frush. Tier 1, 27 months. Been away a while, started a new job, glad you're still here. Yeah, still here. Was your name Dougie always missing the E? I don't remember that. Was your name always missing that E? Yeah, okay, Jax. I was like, wait a minute. Wait a minute. What's up with Capstone? Been out of the loop. Something's weird with the communications on it, Snackless. I don't know the details, to be honest with you. Dougie, it always didn't have the E in it. Huh. That's some, that's some Mandela effect stuff. Anyway. So there was a press conference, and I do have to listen to the press conference, but because we have to get up for that thing in the morning, I think I'll just do it on my own time. Okay. With that being said, we are on. We'll get on to Starship. Yeah, there was some pretty cool stuff that happened with Starship yesterday. We'll just, once again, footage is coming right from NASA Spaceflight. As always, please go over there and subscribe. Go over there and subscribe to the YouTube channel. I would not say that unless I absolutely meant it. I think that asking for subs on YouTube is cringe as frick. I really don't like it. But seriously, you want to keep watching content like this, you know, if you go over there and sub them, you support them. Supporting them over there supports me over here. And I wouldn't, you know how I feel about plugging stuff like that. I really don't like doing that. But also, we get to watch footage like this because of them. Did I mention headphone users? Sorry. Is it just me, or was the last NASA presser kind of a little Screw Space Force tone to it? I didn't listen to it, silly. I gotta listen to it. You want a fresh one? What's the matter, you? You want a fresh one? Quite like that, mates. You see that one, lads? Quite like that one. What? 7 engines, from what I can tell. Oh. So, all right, guys, I was talking with a couple of viewers in chat yesterday before I started streaming. I did a quick stream yesterday. 7 Raptors, okay? The Raptors put out about 2,400 kilonewtons of thrust, okay? So 2,400 kilonewtons of thrust times 7. That's 16,800 kilonewtons of thrust. That's more powerful than one of SLS's SRBs. 16,800 kilonewtons of thrust is more powerful than most launch vehicles that exist. Their liftoff thrust. Most launch vehicles. The only ones that are more powerful that put out more force than what you just saw from that static fire are SLS, the Space Shuttle, N1, Buran. That's it. That's it. Elon confirmed 7 engines. Also commentated that it's a great way to remove dust from the launch site. Yeah, I saw that. Saturn V as well. Yeah, I forgot about that. Saturn, in terms of thrust comparative to a Saturn V, 7 engines is about half of a Saturn V's thrust. Saturn V is 35 meganewtons. That was 16.8 meganewtons. Firing 7 boosters is a little, well, actually, it's a little under half as powerful as a Saturn V. just to understand the amount of force that was just put out there. Yeah, no problem, Hooded. Yeah, Beren was just a pale. I'm gonna hang up. I'm gonna hang up, Dink. I'm gonna hang up. I'm gonna hang up and go drive around my new super seat. Well, I squat 1,700 kilonewtons. You'll be dead. So Elon also set some tentative plans here. He said some tentative plans for what he wants to do, or like where they're going with the booster and stuff. Chamber pressure looked good on all 7 engines, and then Tim asked him yesterday, new record, how long before we see all 33? Elon says Booster 7 is now going to return to the high bay for robustness upgrades, and Booster 8 moves to the pad for testing. The next big test is probably the full stack wet dress rehearsal, then 33 engine firing in a few weeks. Buran flew around multiple times with OKGLI, Dink. Nice try. That wasn't the only time it ever flew. Keepo. Anyway. Yeah, 2 weeks. 2 weeks. Okay, but that's Elon time. Yeah, it'd probably take a little bit longer than that. So here, let's go. Whoop, whoop, whoop. See what else. He's done more crap posting. Oh, it's Kimball's birthday. Neat. Oh. Oh, okay. Great for clearing dust. There it is, Darius. Nice. Let's see. Okay. Yep, don't need to read any of that. Here, there you go. The drone footage makes us look like a bunch of rock stars.
Discovery, go at throttle up.
Baxter, 11-month resub. I think, believe it or not, I think Elon's getting better at managing expectations when it comes to deadlines. You notice how he didn't say, oh, it's going to launch in a week. He said, maybe a few weeks. That drone footage looks so CGI, dude. It really does, doesn't it? But also, here you go. Yep. CSR Starbase has a breakdown of the shackles on the hold down points that hard bolted to the OLM. Darius, I've actually been talking with Zach, dude. I'm going to try to get him on here sooner rather than later so we can talk about Starship. Yeah. Would you guys want that? You would want that, wouldn't you? You'd be like butter looking down at other food items from its special tray. That's Vecna on the left of that meme. Oh, yeah, it is. Okay. Yes, quite. Zach who? Is it bad if I sent this Elon Musk crap post to Brimo the other day and it actually got her to smile? I don't know how I feel about that. Ah, yes. Splendid. Is it wrong that you said Zach and I immediately thought of Hoonigan? I have never... You know what? Zach was not there when I was there, Fox. And that's a shame. But I would love to meet that. That Zach would be cool, too. That guy seems like a really cool dude. Hey, Starship Addicts, check out this massive water deluge ring. Deluge. I'm gonna start calling it. I'm gonna call it a water deluge ring for the Pad 39A OLM. If you zoom in, you could see that this ring is going to be moving serious volumes of water. There are 192 nozzles that will create a waterfall between the OLM legs. by some huge frigging guy. I see a transporter erector and a Subaru and a Toyota and a Ford. OLM bidet. Vertical pipes behind the Toyota. Oh, whoa, mama. That's a lot of pipes. Yeah, the pipe organ that's back there. Ooh. That's pretty neat. Cool. All right, let's see what else NSF has for us here. Oh, there's a new video on different Starship variants. We're watching that.
By design, Starship has a number of different variants. Tankers, landers, point-to-point, and more. But how many different versions of Starship are there? And can we expect any new ones to pop up as its development program continues? Let's go over each variant we already know about, and then do some speculating about what others we might see, including a seemingly new and counterintuitive variant that's just about to be assembled. Let's get right into it, but first, thanks to our sponsor for this video,
Surfshark, yes!
Starship is designed to be a versatile system. Even in its original public unveiling, then known as the Interplanetary Transport System, or ITS, there were at least 3 variants proposed: crewed, uncrewed cargo, and tanker, all of which were related to getting humans to Mars. And since then, as both SpaceX and other industry members have explored possible applications of Starship, the number of variants has grown. By my count, we're around 8 known or proposed variants right now, and there could be more to come. Let's start off with the version we know best, and the one that's flown several times already, the uncrewed suborbital prototypes. These vehicles were very simple compared to the operational versions, and only performed short suborbital hops. SN5 and SN6, flown in 2020, featured just the tank section of Starship, with some prototype deployable legs attached inside the engine section. Both successfully performed 150-meter hops. Later variants, such as SN8 to SN11 and SN15, featured a nose cone and flaps along with 3 Raptors, making them much closer to the final version. Only 2 starships from this group landed, SN10 and SN15, but SN10 landed a bit too hard and exploded due to its methane tank being cracked and leaking. We also, of course, can't forget Starhopper, which flew back in 2019 but had very little design similarity with Starship. And if you want to learn more about the old Starhopper, check out our 2-year anniversary video on the vehicle. Next, we move to the ones everyone is so excited about nowadays, the orbital prototypes. These vehicles feature 3 sea-level Raptors and 3 vacuum Raptors, giving them better performance in the upper atmosphere and the vacuum of space. And since they're going orbital, or at least SpaceX hopes they will feature a full heat shield with over 16,000 tiles. The first in this group was Ship 20, which was expected to make the first orbital flight on top of Booster 4. Although it completed a smorgasbord of testing, it was eventually moved to the Rocket Garden and bumped from the orbital flight for unknown reasons. After scrapping or skipping a few prototypes for an improved version, Ship 24, SpaceX made some upgrades. Ship 24 features all of the previous enhancements, but now has a Starlink satellite dispenser installed. This means that if it flies on the orbital flight test, it will perform some work for the company, deploying the first ever Starlink V2.0 satellites. Ship 24 seems to have completed all or almost all of its pre-flight testing, including some stunning static fires. And be sure to check out shop.nasaspaceflight.com to pick up a metal print of some of the recent Starship testing. Ship 25 seems to be of the same design as well, and no matter what happens on their flights, these 2 ships will provide SpaceX with priceless data on how to improve the Starship system as a whole. But it seems that SpaceX is taking a bit of an unexpected turn with Starship after Ship 25. For a while, we assumed they would keep flying similar orbital prototypes to get data on re-entry and descent, and of course, improve the design along the way. But several strange things are happening with Ship 26. First off, the nose cone for Ship 26 was rolled out of Tent 3 and moved next to its nose cone barrel, which also acts as a Starlink payload bay. This is all normal for Starship, But the strange part is that neither the nose cone nor the nose cone barrel have any heat shield tiles or flap hardware installed. Now, SpaceX may have changed their production sequence, but this would be a huge change and seems like it would just be inconvenient. Other sections of Ship 26 have been spotted with no tiles attached as well, and some that did have tiles were seen having them removed. What seems to be happening here is that SpaceX may be building one or more expendable starships. While this seems odd at first, it could have some good reasoning. It takes longer to build a vehicle like Ship 24 over Ship 26. SpaceX will save a good bit of time, effort, and even money by not adding heat shield tiles or flaps. This gives them the benefit of building and flying vehicles faster, and getting Starlink 2.0 satellites up quicker. Starlink is already very limited in bandwidth, so having more powerful satellites sooner will be a huge moneymaker for the company. Also, they don't really need to worry about re-entry right now. They won't need to return anything from orbit anytime soon. Plus, there are a lot of things that can go wrong in the launch portion, and it may be best to figure that part out first. So it seems that SpaceX may be pausing the re-entry testing of Starship after Ship 25, but this in no way should be seen as them abandoning reusability. Remember how SpaceX abandoned Falcon 9 parachute recovery early on, only to return to testing recovery later, albeit with a different method? This just seems like a shifting of priorities and an acceleration of Starlink 2.0. But now, let's look into the further future. What operational Starship variants will there be? We'll dive right into that after a quick word from my good friend, Jack.
Thanks, Ian, and the Happy Engine for sponsoring this video. Back to you, Ian.
Thanks, Jack. So the first operational Starships to fly will likely be the reusable Starlink deployers. As I said, Starship is necessary to fly the full-size Starlink 2 satellites, so dozens, if not hundreds of these flights will need to take place over the next few years. After that may be a conventional satellite launcher. This would be similar in design to the Starlink launchers, but with an opening payload bay of some kind.
Sorry about that.
We've seen several nose cones being used to demonstrate possible payload bay designs in the past, but Elon Musk has said the design is not firm yet. As a side note, a version of Starship without flaps or a heat shield has been proposed for deep space missions, such as launching probes to destinations far off in our solar system, but not much has been discussed of this version. But SpaceX has signed contracts to deliver satellites to geostationary transfer orbit with Starship, including for SkyPerfect JSAT's SuperBird 9 satellite in 2024. Starship is rated to deliver a remarkable 21 tons to geostationary transfer without refueling. But what if someone wants to launch a heavier payload, or even to geostationary orbit itself? Enter the refueling, or should I say refilling, program. Starship is being designed for something never really done before on this big of a scale. In order to get heavier payloads to higher orbits, or to get any payload to the Moon, Mars, Jupiter, or beyond, Starship will have to refill its propellant tanks in orbit. The first pieces of this puzzle are the propellant depots. As their name suggests, these will remain in orbit and be refilled to act as a staging point where other starships dock for refueling. That way, a ship bound for Mars doesn't need to conduct multiple tanker rendezvous to refill. It can just dock with a depot ship that's already got all the propellant it needs. These depot ships will not have flaps or a heat shield, and may be stretched compared to other vehicles. It's unknown if they will have an empty nose cone or if the entire fuselage will be a propellant tank. The propellant depots will be refilled by the tanker variants of Starship. Like the depot, not too much is known of the tanker specifics, but the idea has been floated around just to use Starships with empty payload bays as early tankers, before moving over to specialized ones that are entirely propellant tanks, like the depots may be. The tankers will feature flaps and a heat shield in order to return to Earth to be used again. Each depot will take several tankers to refill, but the exact number is unclear right now. There's also the uncrewed surface cargo delivery Starship. This variant hasn't been discussed much recently, but would likely feature elevators and even cranes to deliver a payload bay full of materials to the surface of the Moon or to Mars. These would likely fly to Mars before any crew does, just to have a sort of warehouse of materials already staged for crew arrival. And finally, let's discuss probably the most exciting ones, the crewed Starships, the end goal of this entire program. The one being talked about the most recently is the HLS, or Human Landing System. A special starship, without flaps or a heat shield, but with legs and special landing engines, will land 2 people on the moon around 2026 for the Artemis 3 mission. The vehicle will have to be refueled, utilizing propellant depots and tankers, and the exact logistics for that are still being figured out. There's also the conventional crewed starship, with flaps, a heat shield, and crew areas. These would be used for sending people to Mars, orbital flights, as well as point-to-point travel on Earth. This version may be the first to fly with people on board when it lifts off on the Polaris 3 mission in the next few years. So it turns out there's a lot of Starship variants. Around 8 major operational variants have been proposed, to be exact, but more could come about. We could see specialized variants just for the military or for, say, deep space probes. And I'll be honest, the number of proposed variants of Starship even surprised me when I was writing this video. But the Starship system has the potential to be an extremely versatile asset, and it's going to be incredibly exciting to watch it develop, mature, and be implemented all throughout this decade. Thanks for watching. To see what happens with Ship 26 and future vehicles, be sure to subscribe and catch our Starbase videos that show all the goings-on and other activities down at Boca Chica.
Yeah, that was a good video for me in there. Pretty cool. So, what I've often described Starship as is basically so check this out. It's built, the idea is that the modularity of it is built more like a it's built more like let's see, what's the right way to say it? Like an airliner, so to speak. So think like the DC-10. Any tri-jet fans out there? DC-10. Nice plane. It's all right. But then there's the KC-10. KC-10 is the refueling variant of that plane. And then there's just the C-10, the cargo. Oh. I like those. Those C-10s are nice. But there's the cargo variant of that plane, and then there's the civilian cargo variant of that plane, which is just a DC-10 cargo. Oh, whoa! Square bodies, baby. Very nice. Very nice. Very nice. A square body is a very nice. Like pickup trucks. Yeah, that's also called a C-10. Oh. All right. Just look, it's supposed to be like the plane. That's supposed to. The plane. It has variants. Okay, look, it's the same plane. One is carrying fuel. The other one carries people. Oh. Anyway, really awesome video for me in there. Could have done the 707 KC-135. F-100 is better than the C-10. I mean, considering I own an F-100, I very much agree with you. In both planes and trucks. Super Sabre. Nice plane. Yeah. Squirrel! Shut up, Bill! Anyway, Spartan 33-month resub. Actually, they're different planes. They have different liveries. Yep. Or a G550. What the? Bubba? Is that the Bibba? What did they do to it? KC-10 is due for decommissioning in 2023. Oh. Okay. Hey, fellas, here. Speaking of plane news. Oh. B-21. So Northrop Grumman and the U.S. Air Force are unveiling the B-21 in December. What's the B-21? I think a smaller, heavily upgraded, and way more cost-effective B-2. Yeah, that's a B-21. It's like a, yeah, very highly optimized, little bit smaller B-2. Yeah. To say the least. In terms of all of its upgrades, well, all of its upgrades really include mostly and that's really why, you know, they're making the B-21 instead. Yep. Really? Baguettes? Oh, oui, monsieur. Ha 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 ha. Ha ha. I'd be willing to bet the 21 will have its own electronic warfare suite as well. Yeah, from what I understand, it's just basically a modernized, way more cost-effective B-2. Because B-2s are amazing. They're still an amazing bomber, even by today's standards. But they're ridiculously expensive. GTA 6 got leaked. You forget 1,000 things every day. Go make sure that's one of them. The G550 is the trail unit for the NC-37V missile tracking jet based on the G550 platform. I'm talking G5. G5 for chat. No more frequent flyer Gulfstream miles from my boy. Oh, yeah. Playa. You said that seeing green after the engine shut down is a bad thing. Is that what happened? Is that what is happening here? No. Apple bottom jean. Oh, you're just so very, very, very white. I'm not white. I am tan. Look. Look at the tan. Anyway. Playa. I'm starting meetings with Gulfstream for the design and finishing of my company's G800 in January. Wow. Well, aren't you special? No, that's really freaking cool, actually. All right, dudes. I think we got it all. From reusable launch vehicles to reusable third stages to MiG welders, Starship, and everything in between. I'm pretty sure we actually got everything. Are we doing the Hostler Blend? Well, actually, Flykin, I was going to start winding down here because I need to be up at 7:30 for an SLS. Well, at 7 for an SLS press conference. So, yeah. How about we make this one only an 8-hour stream and we make tomorrow like a 15-hour stream? I'll give you a very good reason as to why. I mean, obviously there's the media press conference, but also I got this for you. Take a look. And we got a Neutron update tomorrow at 1:30. Yep. Okay. So it looks like we're going to have to play that tomorrow. Leaked pictures the B-20. Oh, yeah. Yeah. That's right. Yep. Okay. All right. That looks pretty awesome. We will do the SLS press conference early in the morning tomorrow, or the SLS tanking test. That's what's going on. The tanking test is early in the morning. And then, yeah, I guess we'll just go all day tomorrow. Then we could do Satisfactory. We could play more cities. We could play more Hasterplan. We could do all three of those things tomorrow. And then at 1:30, we have the Rocket Lab Neutron announcement. We got an update for Neutron. And you know what? I think the last thing we'll do here for Space News is see what we have teed up to launch. Okay. All right. MS-22 is tomorrow. Yeah, it's tomorrow. That's at... Oh. Huh. Okay. Then we got Delta 4 Heavy, and then Falcon from like 40 to, yeah, Delta 4. That's the L91 mission, yep. And then Starlink, and then ABL. Oh, wow. We have, there's a lot of stuff. Oh. EJ is excited for the 3 a.m. Firefly launch. That's on the 30th, though. It's on the 30th. It's actually not on one of my days off. Every time they put it on my day off, it's scrubbed. See? Don't put rocket launches on my day off. Same with that Falcon 9. But then Falcon 9 did launch the other day. Shh. Anyway, what time is SLS? SLS is tentatively scheduled for the 27th. Oh yeah, Foz, we should leave on. We'll leave on that. We will leave on this very, very informative video from United Launch Alliance. This is what we'll end on. That is a video from ULA Actual, and it's called The Most Metal of Rockets. Delta 4 Heavy Metal. You know what? I'm watching it again. What's that? Literally just watched it. You can pick it up. The noise gate didn't work for the metal strip. Did you see that? Oh, that was... Dude, that's a shame. Wait, ready? There we go. There we go. Now it's good. Now, it worked that time, but it was not... But... You're planning on seeing the Delta IV heavy launch at Vandy. Nice, Funky Flex. There you go. It's gonna be sweet. Yeah. See, you gotta have the metal scream. Give me the wake up at the... Yeah, wake up. That's a good song. I think Starship has more metal than Delta IV. Yeah, but Starship doesn't light itself up. I mean, it kind of does, but yeah. Channel your inner Jack Black metal scream. I can do that. I'm just... It's... The noise gate is gonna go... Here. How about... Highway Star? Here... Nobody gonna take my car. Yeah, yeah, yeah. That's good, right? That's not bad. That's pretty good. Sometimes Starship just blows itself up. Yeah, yeah. Yeah. Anyway. All right, dudes. I'm gonna wind it down.